LaTeX is a typesetting system for creating professional-looking documents, commonly used in academia and scientific publishing, with a focus on content rather than appearance. Michelle Crummell is your instructor in this LaTeX course for beginners. She is an experienced teacher with multiple mathematics degrees.
Welcome, I'm Michelle Crummell, and in this video I'm going to show you how to get started using LaTeX. LaTeX is a document markup language, and it's used to create professional-looking documents with consistent formatting. It's especially useful if you're typesetting mathematical notation, so it's great if you're writing a paper that contains mathematics, if you're creating tests and quizzes, or typing up homework assignments. I use it for other things too, like creating slide presentations and even writing letters of recommendation. It has many uses. As a teacher, some of the main reasons I prefer using LaTeX over word processors, besides just how professional the output looks, is that LaTeX is cross-platform, it's backwards compatible, it produces PDF files that are small and can be opened on any device, and it's free, open source, and highly customizable. But before you get started creating your own LaTeX documents, you have a decision to make. Do you want to work and store your files online or offline? The advantages of working online are that you don't have to download, install, or update any software onto your computer. So you can get started right away. You can even work collaboratively in real time using shared documents. The advantages of working offline, on the other hand, are that you have complete control over how you organize and store your files, and you don't need an internet connection to work on your files. Both options work really well. It just depends what's going to be best for you. So I'm going to start by showing you how to work online, because for a beginner, that's probably the fastest and easiest way to get started. So to work online, we're going to use a website called Overleaf. So you can just do a Google search for Overleaf, or you can go right to overleaf.com. Now, I already have an account set up, so when I went to overleaf.com, it automatically logged me in. But if this is your first time visiting Overleaf, you will want to create an account, and you can do that using an email address. So because I don't have any files created so far in my account, this is the screen I'm seeing when I log in. Once you create at least one text file, you're going to see a different screen when you first log in, and you'll see a list of all of your files. But for now, we're going to click on Create First Project, and we want a blank project. And you're going to have to come up with a name for your project. I'm just going to call this Tutorial 1. So when we create a new project in Overleaf, it's automatically going to populate some code for us. This is really just the basics here. And we can see that we have sort of three windows here. On the far left, this is going to show us our file structure. The name of our text file is main.tex. And then in the middle here, we have the place where we're going to be typing our code. And then over on the right, we have our PDF output, so we can see what our final document is going to look like. So just a couple of things to point out here. When you make any changes to the code and you want to see what they look like in the output, you are going to have to click Recompile. When you make changes over here, it's not going to automatically update on the right. You do have to hit Recompile. And generally, if you're not working in Overleaf, you're not going to get this sort of starter template here. You're just going to have an empty slate to work with. Now, if I try and compile right now, I'm probably going to get an error because there is no code. Let's see what happens. Yeah, so it's not giving us just a blank PDF. It's actually coming back with an error and saying that it can't compile the code. And that is, of course, because we don't have any code. So let's just do some really basic code in Overleaf, and then I'm going to switch over and show you how you can work offline. That's my preferred method, and that's what I'm going to be using in my future tutorials. So to start our document, we're going to hit backslash, and we want to make sure that we are always using the backslash and not the forward slash. So the backslash is starting our command, and then I want document class. Now, as I start typing document class, you can see that it's kind of guessing what I'm going to be typing, and I can now just click on that to complete the command, or I could have just continued typing it out with my keyboard. So we have document class, then we have a pair of square brackets followed by a pair of curly brackets. And we have to type something in these brackets. This is part of the code. So in the curly brackets at the end, we're going to define what kind of class that we're using. And for us, it's going to be an article. Now that doesn't mean we're writing an article like a newspaper article, but that is just the name of the class, the type of document that we are creating. There are other document classes that you can use. For example, if we had entered Beamer there, we would be creating slides, almost like a PowerPoint presentation. If we typed exam there, then we have a different type of class that I use for creating tests and quizzes. But most of the time, I use article. Now the square brackets, these are for optional arguments. So I could actually delete the square brackets and not use them at all. I could even just leave them there blank with nothing inside. But here we can type some options. So one of the things that we can type in here is the font size. So I think the default is 10 point. I'm not sure. I always use 11 point, so now I can't even remember now what the default is. But if we want to use 11 point instead of 10 point or 12 point, then we can type that. The PT stands for point, and that's going to change our font size. Now, if I try compiling right now, I have some code here, right? I suspect I'm still going to get an error. Yeah, I'm still getting error because I haven't really started my document yet. There's no real content in here. So that's like the bare minimum that you need to declare before you actually begin your document. The next thing we're going to type is / begin, and then in curly brackets, document. So again, it's anticipating what I want. I can just hit enter and it will fill in for me, or I could have continued to type it out on my keyboard. Now, when I hit enter, notice not only did it give me begin document, but it also gave me end document. So this is a command that comes in a pair. It's got a begin and an end. If you type / begin document and you forget to type / end document, your file will not compile. So it knows when it sees a begin to be looking for a matching end. So we want to make sure and do that. And it's a good idea to go ahead and just type the ending command and then move your cursor back in between and type the rest of your content so you don't forget. And let's do just something really basic like hello. And I'm going to compile, recompile, and see what we get. So we do have something now, something on the screen. You can see that not everything I typed in the code is showing up on the screen. The commands aren't going to show up, but the text itself is. And we can use the color coding to kind of give us an indication of what's what. So the text that I typed is colored black, whereas the commands, the / document class, / begin, / end, those are blue. So we can distinguish between them. So let's type a little bit more than that. This is my first LaTeX document, and recompile. It's a good idea to compile frequently because if you wait for too long before you compile, you may end up with 5 or 6 errors, and then it's very difficult to go back and figure out exactly where the errors happened. Ideally, you would only want, one error to deal with at a time. So it is a good idea to compile frequently, and that way you can catch any errors right when they happen. All right, so hello, this is my first LaTeX document. And you may have noticed, if you've been kind of looking at things online, that the word LaTeX is often typeset in a very particular way. It's kind of got a special font, if you will, to make it look a certain way. And we can very easily accomplish that here by putting a / in front of LaTeX. Now you do have to spell it exactly how I spelled it, with a capital L, a lowercase a, a capital T, a lowercase e, and a capital X. So let's recompile and see what happens. Now actually this doesn't look great. I mean, it's nice that the word LaTeX is typeset correctly, but there's no space between the X and the word document. So to get the space in there, I'm going to just put another / at the end of that command. Okay, and that fixed that right up. Now you might be wondering why It's spelled LATEX, and I keep saying LaTeX and not LaTeX. The letter at the end of the word is actually not an X. It's actually the Greek letter chi, and the Greek letter chi sounds more like a K than it does an X. It doesn't sound exactly like a K, but that's the closest, I would say, letter in our alphabet to what it sounds like. So it's like a hard K sound. It's not an X sound at the end. A lot of people say LaTeX instead of LaTeX. Both are correct. It's just a matter of preference. So there we are. We have just a really basic document that we've gotten started here. And I do want to do a little bit more with this to explain, especially like how line breaks and some very basic formatting works. But I'm going to go ahead and switch over now to working offline and show you how to do that. If you have lots of LaTeX files like I do, I mean, I have thousands and thousands of LaTeX files that I create. I prefer to be able to store them on my hard drive. If I'm working in overleaf, everything kind of gets, let me go ahead and show you before we leave. I'm going to hit this up arrow to go back to kind of this main screen here. And if I list all my projects, I only have this one that I created, tutorial 1. But as I start creating more projects, you're just going to see a long list of files here. I like to be able to put things in folders and subfolders, and in some cases subfolders, and move things around on my computer to store things the way that I want. So that's the one downside I personally find with using Overleaf, is just the file structure and how you store and find things. Now you can tag your files, which does allow you to filter things and make it easier to find. So instead of having a list of 100 files, maybe you can narrow it down by tags, and that does help a bit. So if you do want to work offline, you are going to need to install some software on your computer. And there are 2 pieces of software that you need to create LaTeX documents. You need a LaTeX distribution, and then you need a text editor. So the LaTeX distribution is what is going to turn your code into some kind of output file, like a PDF file. The text editor is just what you use to type the code. And there are all kinds of text editors, right? You can even just use Notepad, something really basic, as a text editor to type your code. It's important when you're installing these 2 pieces of software that you do so in the correct order. Install the distribution first. You need to install your LaTeX distribution first. So I get quite a few comments of people asking for help and saying, they're trying to compile their first file and it's not working. They're getting errors. It's really important that you install your distribution first, so that's up and running, and then install your text editor and try using your text editor. Okay, so what should you install? Well, there's lots and lots of options, and then your options are going to be different based on whether you are a Windows PC user or a Mac OS user. So if you have a Windows computer, then my recommendation is to install Mictech as your LaTeX distribution. You're going to do that first, and then to install TextMaker as your text editor. Now, Mictech, when you install it, does come bundled with its own text editor, and you can use that. I just don't find it as user-friendly as TextMaker. TextMaker is so wonderful for people who are starting out with all of the nice options and the way that it color codes things and the way that you can create macros. I really love TextMaker, and even though I'm not a beginner, that's still my go-to program for editing LaTeX code. If you are a Mac user, I'm a Mac user, then you want to install Mactech for your LaTeX distribution and TextMaker for your text editor. Okay, so again, please install your distribution first. So that's either Mictech or Mactech. And then once that is installed, you can install the text editor. And all of this is absolutely free to download, install, and use. So here I am in TextMaker, right? So because I'm on a Mac, I've got Mactech installed as my LaTeX distribution. Now, Mactech is not something that you would ever click on and open. It just works in the background. The text editor is what you're going to interface with. So I don't have to worry about Mactech or creating a shortcut to it or anything like that. You can, once you have it installed and it's working, you can just completely ignore it. But TextMaker, my text editor, is what I am going to use to create my documents and type my code. So right now I'm in TeXmaker. Now this isn't a fresh install, so I'm not sure that my screen looks exactly like what you will see when you first log in. It's possible that that you have, let me see, this structure thing turned on here. I'm just clicking through some of these. Right now, what I'm seeing looks more like what we saw in Overleaf, where you've got some information over here. I mean, there's nothing here yet because we haven't created anything, but some file structure information over here. And then in the middle is where we will be typing our code. And then over here on the right is where we will be viewing our PDF. But to save on some screen space, I really don't need to see the structure tab. So I'm going to turn that off. And then my messages log, I mean, I can turn it off. It's going to automatically come back up when I compile, so it's not that important. The PDF viewer, I do want to be able to see my PDFs as I work, so I will leave that showing. Now we don't see anything because we're not actually working in a file at the moment. So the first thing we're going to do here is to create a file. Actually, the first thing we should do is look at our preferences and make sure that we have some good options selected. So I'm going to go into TeXmaker. Sorry, that's just cut off. You can't see that, but if you go to your menu here, click on TeXmaker and Preferences. And I think it's different on the Mac version. If you are on a Windows PC, you might have to go to like Preferences or Options, but somewhere in here you should be able to pull up the window that I'm seeing right now. So it might be called Options or it might be called Preferences based on whether you have the Mac version or the Windows version. Okay, so what in this first screen, for this commands tab, you want to make sure that you have this box checked right here, PDF viewer. We want to embed the PDF. That's what's going to allow us to see the PDF on the right and the code on the left. So we want to check that box. I'm using my built-in viewer to view the PDFs. And then you also want to check this box down here, launch the clean tool when exiting TeXmaker. That's really useful. When you create LaTeX documents and you close your document, you're going to see a lot of files that are created in that process. You have your text file, you have your PDF file, and you have like log files and a bunch of other files. And really the only ones that you are going to need are the text file, which is, your source code, and then your PDF, your output. So just those two files. So if you click Launch the Clean tool, it will automatically delete all of those like helper files and make your folder structure and navigation so much easier to deal with. If we go to Quick Build, you want to make sure that you've selected PDF LaTeX plus View PDFs if your intention is to create PDF files. Under Editor, you can change some of these options if you like. I normally don't have my font size this large, but for the purposes of the video, I want you to be able to see what I'm typing more clearly, so I increased that. I usually have it about 16. Word wrapping, I recommend that you do keep that on, and completion if you like that. That's if you start to type a command, it's going to suggest what it thinks that you're trying to type, so you can just hit enter. And then show line numbers is also really helpful. Because when you get error messages, sometimes you can look at the line number and go right to that line number and try and figure out what the error is. Back up your document every 10 minutes. You can turn that on if you like. I don't have any particular reason why I did not have it turned on. Let's see, everything else looks pretty good. Shortcuts, these are just keyboard shortcuts that you probably don't want to worry about when you're first starting out, but you might want to take a look at those as you get more comfortable with this. Okay, so let's create our first document. Now you do have to actually create a document. So I'm going to click on New here, or you can use the menu and click on File, New. Now this new document here, it says Untitled. We haven't saved it yet, so I haven't actually created anything. And even if I type some code and try and compile it, I'm going to get an error message. You have to save the file first, name it and save it first before you're going to be able to compile it. So don't skip that step because that can be frustrating. You're wondering why this is not working. You actually have to save the document. It's not enough just to say, I'm creating a new file. You actually have to save it. So file, let's save this. And I'm just going to call this tutorial 1. Tutorial 01. Now, one thing I want to stress here is that you should never use spaces in your file names for your tech files. Don't use spaces. If you don't like your words all running together, you can do something like a hyphen. Hyphens are fine if you want to do that. You can do an underscore if you want to do that, like if you want to put multiple words in your title. I usually do an underscore when I name my files, but do not use a space. So I'll just keep the underscore in here. And the file extension is going to be .tech, but that's, that's going to happen by default. So I don't really have to type the .tech when I am naming that. So I'm going to just open up that folder and show you what I've just created. Okay, here we go. So this is my file that I just created, tutorial01.tech. And you can see that there aren't any other files in this folder. So let's go ahead and recreate just the basic code that we had when we were using Overleaf. So / document class, and I'm going to fill that in. I think we had 11 point. It's an article. And then / begin document, and we have our end document, and then we said hello. This is my first LaTeX document. Now, to compile this, we see that we don't have a recompile button like we did in Overleaf. I'm going to click on this arrow to compile the code. And it used to be I just clicked on this arrow and it would run both of these. I'm not sure what my issue is at the moment, but it's making me click both arrows, like over here to compile and then here to view the PDF. This isn't generally the way I do it. The way I generally do it is to just hit F1 on the keyboard. So as I'm working throughout these tutorials, if you wonder like how does it seem to be refreshing so quickly, you didn't see me come up here and press on the arrow, it's because I just hit F1 on my keyboard. That's a really fast way to do it. Oh wait, I think I do know why that's not working quite right. So the PDF LaTeX will compile the code, and then view PDF is going to refresh the PDF so we can view it over here. But if I want to do both of those things at once, what I actually want to select here is Quick Build, so that when I click on this arrow, it's going to do whatever I have saved in Quick Build. And if we go back to our preferences, Quick Build is right here. I have PDF LaTeX plus View PDF in my Quick Build. So when I choose Quick Build, it's going to do both of those two things. And then while we're in here, I'm going to go ahead and uncheck this backup every 10 minutes. And the reason I'm going to uncheck that is because if I leave that on, then not only am I going to be creating a text file and a PDF, but I'm also going to be creating a BAK file, and I just don't want to have all of that stuff in my folders. It's absolutely not a big deal. If you want to leave it on there and have backup files in your folders, that is perfectly fine. So here's what we have so far. Hello, this is my first LaTeX document, and we can fit this to the width so it's a little easier to see. We can, zoom in or out, fit it to a full page. And so I'm going to continue to work in TeXmaker, but if you are more comfortable working in Overleaf, you don't want to hassle with trying to get the software installed and up and running, that is perfectly okay. You can still type the same code that I'm typing, and your output should look exactly the same. I'm going to go back to fit width so we can see this a little bit better, so it's not too small on your screen. And let's move on. So I have, one line typed here. Next, I want to type a little bit of math. So I'm going to say a rectangle has side lengths of x plus 1 and x plus 3. So let me hit return and type that out. And because this is in a sentence, I know that it would look better if I used parentheses around the x plus 1 and the x plus 3. So let me do that. And let's compile and see how that looks. So again, you can use the arrows up here. I'm just going to hit F1 on my keyboard, and this is what we have. Now, this might look okay to you. It doesn't look that great to me. There's a couple things I want to point out. The first thing you might notice if you're used to working with a word processor is that a rectangle has side lengths of x plus 1 and x plus 3 is not on a new line. It just continued at the end of the first line. And when we look at the code, that's not what we might expect to happen, because in a word processor, when you hit return right here, then the output actually shows that you hit return right there. And that's not going to happen here with our code. Our code is only going to create a line break if we tell it to create a line break. And there are two ways to create line breaks. And the same thing is true in a word processor. There's two ways to create line breaks. You can do a soft return, you can do a hard return. So a hard return is going to start a new paragraph. If I want a hard return, what I want to do is to just insert a blank line in between, hello, this is my first LaTeX document, and then the next sentence. So if I leave a blank line in between those two sentences, then the compiler knows to insert a hard return. So let's recompile that. And now we can see that we did in fact get a hard return. So a rectangle has side lengths, blah, blah, blah. That is the second paragraph now. That's a hard return. If you want a soft return, so let me go back here. If you want a soft return, then at the end of your line where you want the line break, you type 2 backslashes. Okay, so we will compile that. And now we can see that we got a new line for a rectangle has side lengths of. However, this looks a little bit strange, right? It looks different than what we saw before because a rectangle is starting further off to the left than hello. This is a soft return, so it didn't create a new paragraph, and therefore the line is not indented. So by default, I haven't typed much code, granted, but by default here, new paragraphs are going to be indented. So the hello is indented. A rectangle is not indented because it was just a soft return. It's not a new paragraph. Now, you can do something like this, but it's not preferred. What's going to happen if I do this? Let me turn on my messages log. Oh, it actually didn't mind it. Okay, I was expecting it to not like the combination of the soft and hard return there, but it seems to be okay. I like having this space in my code because it makes it easier, for me to go back and find things versus this where everything just kind of runs together. But you can decide which one you like better, a soft return or a hard return there. And there are also ways that you can turn off the indenting because remember, whether you do a soft return or a hard return is going to affect the way that your paragraphs are indented or your lines are indented. So let's go ahead and do a hard return, right? These do seem like they're probably separate paragraphs. We'll update that. I'm just using F1 to recompile. And there's still an issue here, something that's okay, but it's not great. And that is that the X that I typed doesn't look like math. It just looks like the letter X, as if I had typed a word with an X in it. So when we type variables in math, typically we want them to be italicized, so they look like variables. And that's going to happen automatically as long as we tell the compiler that, hey, this is math, it's not text. So we're going to use something called math mode. To enter math mode, you type a $sign to start math mode, and then another $sign to end math mode. And you can see that the color changed when I did that. When I typed that first $sign, everything after the $sign turned green. So math mode, things are going to be green. And then when you end math mode, everything that's outside of math mode is going to go back to its normal color. So the word and is black, that's text mode. Okay, so math mode, text mode. And I want this x plus 3 to be in math mode as well. So I'm going to type $signs around the x plus 3. And let's recompile. And we can see the difference visually. Now that X is italicized, the spacing is a little nicer because it knows that it's math and it needs to space things in a certain way to make everything look uniform. All right, I'm going to add some more to this. I'm going to add another sentence. So we have a rectangle has side lengths of x plus 1 and x plus 3. I'm going to say the equation a of x equals x squared plus 4x plus 3 gives the area of the rectangle. So I want you to just anticipate what's going to happen when I compile. What do you think this is going to look like? So I'm going to hit F1 to compile, and I have encountered my first error. Okay, I can see that below here. These things are popping up in red. Something has gone wrong. Something's wrong on line 6 and line 7. And it's kind of giving me an indication. It says missing $ inserted, right? It didn't actually insert it for me, but that is a clue for me of what went wrong. Oh, I probably forgot a $ somewhere. So a of x equals x squared. Now the letter a, the letter x, like those could be text, so that's not what caused the issue. I think it was this symbol right here, this caret symbol. Is only going to work in math mode. It's not going to work as text. So I'm going to put my equation in math mode by typing $ around it, and now we should be okay. So again, we see that the paragraphs are indented. Now that the paragraph is long enough to wrap down to another line, we can see the way the indenting is working here. So things are not great, right? This is okay. It's in math mode. The math actually looks good, except for the fact that a of x equals is on one line and then the rest of the equation is on another line. So that's not great. If you want to make sure that to keep your equation on a line, you can put curly brackets around it. And now when I recompile, it's going to protect that for me. So a of x equals x squared plus 4x plus 3 all got pushed down to the next line. Okay, so looking pretty good. Still, like, if I mean, I'm still not that happy with it. I think there should be some space between the paragraphs, right? But, you know, we're just talking about the basics right now. So the next thing I want to tell you about is the difference between, there's kind of two different math modes. There's displayed math mode, and then there's inline math mode. If you use displayed math mode, whatever is in your displayed math mode is going to be on its own line. So we often see this in math textbooks, where equations are put on their own line. And to enter displayed math mode, all you have to do is type $2 to begin displayed math mode and then $2 to end displayed math mode. So let's recompile. And now we see that the math in displayed math mode got centered on its own line. And there's some nice spacing there to separate it from the text. And then the text just continues after that. This is still happening like within a paragraph. Versus inline math mode, like the x plus 1 and the x plus 3, those just appear in line with the text. Okay, so we've covered some basic information. Let's go ahead and I'm going to close this and then just show you now what I have in my folder where I created my text file. Okay, so if we navigate back to the folder where I created and saved my text file, now I see there are actually two files there. There's the text file that ends with .tex, and then there's the PDF file. So the text file is our code, and here we can just see what just the text, the code itself looks like. There's a little preview of that, and then here is the PDF. So that's not all fitting on the screen. Let me make that a little smaller, and there we go. Okay, so that is the PDF document that I created. Check the description below for links to the files I created in this video, as well as links to the software that I recommend using. In the next tutorial, we'll look at how to typeset commonly used mathematical notation using LaTeX. Hello, I'm Michelle Crummell, and in this video I'm going to show you how to type commonly used mathematical notation in LaTeX. I'm working with the software program called TeXmaker, but you can use any text editor that you like. If you watched my previous video creating a LaTeX document, I showed you how you can use Overleaf so that you don't have to download and install any software. Overleaf runs right in your web browser. So there is a link in the description below that you can click on if you want to create an Overleaf account and work purely online. If you want your screen to match mine exactly, you're going to want to download TeXmaker. Make sure that you do have MikTeX or MacTeX installed before you install TeXmaker. So I am in TeXmaker right now, and I'm going to create a new file. So just click on that icon here, and it looks like I have, a new file ready to go. It looks like it might be called Untitled1, but actually we haven't saved this. We haven't really created it yet. So before we start typing any code, this is very important. We need to save this file and name it. Otherwise, you could type all kinds of code in here, and when you go to compile, you're just going to get an error, and it's not going to be able to do anything. We have to save this file and name it first before we're going to be able to compile it. So let's do that. File, we'll save as, and you can save it anywhere you like on your computer. I'm just going to call this one tutorial 2. And I mentioned in my last video, you don't want spaces in your file names. Your TeX files should not have any spaces in the file name. So use an underscore or a hyphen, or simply just, run all of the words together. And that will automatically assign an extension of .tex to that file. So here's my tutorial 02 TeX file, and now I can start typing my code. So we always start with \document class, and TeXmaker is making this suggestion for me, so I can hit enter as a shortcut here and have it fill in some of that for me. Now the square brackets are where we would place optional arguments here. It's unnecessary. If I didn't want that, I could delete that and just have the curly brackets. We do need the curly brackets here. The class that we are using today is article. So that's fine, I can do that. If I do want to include some optional arguments, one of the more common ones would be to declare the font size. So your choices are 10 point, 11 point, or 12 point. I usually like to go with 11 point. And then we're always going to have \begin document and \end document, that pair of commands there. So I'm not going to compile yet. I don't actually have any content. We have to start typing something first. We're working on mathematical notation today, so I'm just going to go through lots of different categories and then show you how to type various expressions that you might need. So let's start with superscripts. So I'm just going to type the word superscripts, and now that I have something here, when I build, we should be able to see that. And I'm just going to set this to, oops, not that. We just set the width here so that we're seeing the whole page. That looks about good right there. Okay, so superscripts, and we want to actually type something with a superscript in it. So that was just in text mode, and I'm going to type 2x to the power 3, so 2x cubed. 2x, for the exponent, we use that caret symbol from the keyboard. So there's 2x cubed. However, if I compile this right now, I'm going to get an error because this caret symbol needs to be in math mode, not in text mode. So to put this in math mode, remember we wrap it in $signs. And now I can build. So I'm building by hitting this arrow up here, which is quick building for me. So it's doing two things. It's compiling the code and producing the PDF that we see over here on the right. But I usually prefer to use my keyboard shortcut, which is just F1. So if you don't see me come up here and press this button in the video, then it's because I just hit F1 on my keyboard. If I hit F1, then it will compile. So I can tell that the 2x cubed is in math mode because it turned green. That's one of the nice features about TeXmaker that I like. It does color code different parts of the code, so it's easy to keep track of what you're doing. And if we look at our results, we've got, it's okay, superscripts 2x cubed, but I would like to separate the 2x cubed from the text and put it on its own line. So we're going to do that by using displayed math mode. I'm going to use $2 symbols at the beginning and the end of that, and it puts the math mode on its own line centered on the line, like so. So next we're going to look at 2x to the power 34. Again, I'll use this displayed math mode, 2x to the power 34. So think about what that's going to look like. The fact that I used double dollar signs means it's going to be placed on a separate line and it'll be centered on that line. So I don't have to worry about putting in any kind of manual line break like we practiced in the first tutorial. The double dollar signs will automatically start a new line for me, so that's fine. But if I want 2x to the power 34, what I'm expecting to see is x in the base and 34 in the exponent. And if we build this, and let me zoom in a little bit more so it's easier for you to see. If we build this, you can see that the 4 didn't go up into the exponent. So by default, when you use this caret symbol, only the single digit that comes next is going to be placed in the exponent. If you want more than that in the exponent, then you have to use curly brackets. And you can use the curly brackets even if you only have a single digit, but I normally don't bother. If it's just a single digit, I don't bother putting the curly brackets. But now when we compile, we can see that the 34 has moved up into the exponent, which is what I had intended. So another example, let's do 2 times x to the power 3x plus 4. 2 times x to the power 3x plus 4. So if I want 3x plus 4 all to be in the exponent, then I need to put curly brackets around that. And that looks like I expected it to look. And then let's do 2x to the power 3x to the 4th plus 5. So we're going to have an exponent inside of an exponent. So 2x to the power, curly brackets. Now generally when I'm doing this, I find it quicker and easier if when I type the first curly bracket, I go ahead and type the end one as well. So that way I don't forget it at the end, especially if I'm going to be using multiple curly brackets. Just makes it less likely that I'm going to forget to close one of my opening brackets. And then sometimes I'll even just go ahead and do the same thing with my dollar signs. And then I can just back up and enter what I need to inside of the brackets. So we're going to put 3x to the 4th plus 5. 3x to the power 4 plus 5. So this exponent here, I didn't bother to use the curly brackets. I could have wrapped the 4 in curly brackets, but since it's just one single digit in the exponent, it's unnecessary. Okay, so now we have 3x to the power 4 plus 5 all in the exponent here. And now let's move on to subscripts. Subscripts work in a similar way. So let's start with x sub 1. X sub 1. To get the subscript, you use the underscore. Is that what it's called? Underscore, and then whatever you want in your subscript. And again, it will only put the next single digit into the subscript unless you use curly brackets. So here we've got x sub 1, and if I want x sub 12, for example, x sub 12, this is not going to work. It's still going to just do x sub 1 and then put a 2 right next to that. So that's not what we want here. We want 12 to be in the subscript, so we put curly brackets around the 12. And now we've got 12 in our subscript. You can have subscripts inside of subscripts as well. So let's just do x sub 1 sub 2. And I think this might cause an error if we just type it like this. Yes, it did cause an error. So we have to use curly brackets here so that the compiler knows what it is we're trying to do, because it's different if you want x sub and then 1 sub 2 versus x sub 1 sub 2. So you have to decide how you're going to put your curly brackets, where you're going to put your curly brackets. Generally, I would say x sub and then everything you want in the subscript should go in curly brackets like this. Now look inside your curly brackets. Do we need more brackets? Well, since there's just a single digit after the 2 right here is just a single digit after this subscript, we should be okay with this. Let's see how that looks. So that's x sub 1 sub 2. And we could even go further with that if we wanted to do x sub 1 sub 2 sub 3, like so, but we're going to have to figure out our brackets. So x sub, and then use curly brackets around your entire subscript. Now within that curly brackets, we need more brackets because we've got 2 subscripts in there, so we want to be clear. 1 sub, and then we'll put curly brackets around the 2 sub 3. So I'm like nesting my subscripts here. Let's see how that looks. So 1 sub 2 sub 3. And you could continue, to do this as many times as you need to. So let's do one more example. Let's say we have a sequence, and I'm not going to use the curly bracket notation, and let me just list some values. So we might have a sub 0, comma, a sub 1, comma, a sub 2, comma, and then I want ... I'm not going to type the ... There is a LaTeX command for that. \L dots is going to do 3 dots. The L is for lower. They're going to be aligned at the bottom, like lower aligned, versus C dots would be aligned in the center. But L dots will work for me fine right here. And then we'll say a sub 100. Now with 100, again, I'm not going to type it like this, or it's only going to be a sub 1 and then 2 zeros next to it. That's not what we want. We want 100 to be in the subscript. So we need curly brackets there. There we go. So a sub 0, a sub 1, a sub 2, ... a sub 100. Next, let's look at some Greek letters. So we often use Greek letters in math notation, and one of the most popular Greek letters that we use is the Greek letter pi. If you want to type pi, it's just \pi. Now that is the lowercase pi. If I wanted the capital Greek letter pi, \PI, like so. And that's the capital pi. If we want other Greek letters, we can just type the name. If you use a capital letter, it's going to give you a capital Greek letter. If you use lowercase, it's going to give you the lowercase Greek letter. For example, we can do \alpha. And that's going to give us the lowercase Greek letter alpha. So you get the idea there. And we might do something like A equals pi r squared, right? Area of a circle. So \pi. Now it's important here that I enter a space and then do my r squared. Otherwise, if I don't have the space there, let me take out the space and show you that because it's all running together, the compiler sees the command as \PIR. \PIR is not a valid LaTeX command, so it's going to get confused and we're going to get an error. Pretty sure we're going to get an error. Let's try. Yep, we're going to get an error. And you can kind of see it's giving me a hint here of what the error is. It doesn't like that PIR. So you have to put a space between your command and the next thing. And now it should be fine. There we go. Area equals pi r squared right here. Okay, so those are Greek letters. You can do many other Greek letters. I'm just showing you an example of a few. Let's talk about some trig functions. If we want to enter, for example, y equals sine of x, y equals, you're going to use a, first let me do it the wrong way, because beginner students often will just type this and they might not even think there's anything wrong with the way that looks, right? I mean, you can read it. It says y equals sine x, but it is not displaying the way we would like our mathematical notation displayed. The compiler, because you're in math mode here, thinks that the s is a variable, the I is a variable, the n is a variable, and the x is a variable. And so it's typesetting them all the same way. And you can see it looks very uniform the way these letters have been typeset. They're all italicized and spaced kind of the same way, and they're all running together. That's not how we want the sine of x to look. So we put a backslash in front of our trig functions, sine, cosine, tangent, secant, cosecant, cotangent. And now when I compile, you can see the difference. The sin is not italicized, and there's a little bit of a space between the n and the x. Okay, so this is how it's supposed to look. And we can do that for our other trig functions, like I said, y equals cosine x. Tangent x is tan, backslash tan. If we want to do the reciprocal trig functions, y equals, let's just do cosecant, is CSC. Secant would be SEC, cotangent would be COT. And instead of x, let's just do theta. So theta is one of our Greek letters. We're going to do backslash and then type out theta. I want a lowercase theta here. So we've got y equals cosecant theta. And you can play around with it and see, what happens if you did a capital theta. Well, we would get the Greek capital theta, but that's not what we normally use for angles. We use the lowercase. There we go. So you don't want to forget when you're doing your trig functions, sine, cosine, tangent, secant, cosecant, cotangent, to put the backslash in front and the space between the trig command and then the argument or the angle. We can do inverse trig functions as well. So let's do sine inverse of -1. Y equals sine inverse, so backslash sine. And then for inverse, that we're going to use the notation where it puts a -1 as a subscript. So remember how we did subscripts. It's the caret. I want -1 in the subscript. So I can't just do this. That's not going to work. That's only going to put the negative symbol in the exponent. The 1 will not be in the exponent if I do that. So I have to use curly brackets, -1, like so. And then of x or theta or whatever we happen to be using. Oh, I did say sine inverse of -1, didn't I? Although that's a little confusing because we would have -1 in two different places. But if I wanted the sine inverse of 1/2, for example, we haven't done fractions yet. We're about to do fractions. Let's keep it simple. Sine inverse of 1. There we go. Could do that. Or theta or x or whatever we need there. Okay, so that's sine inverse. Now we could also use the arc sine notation. Instead of using that -1 superscript, we can just do y equals arc sine, and it again is backslash, and then you type arc sine, ARC SIN, and then your angle. Okay, so by putting the backslash in front of the arc sine, it's indicating to the compiler, hey, these are not variables, don't typeset them like variables. So it looks like it's supposed to look here. Okay, let's do log functions next. And we will start with just a common log, y equals log x. Now again, think about what's going to happen if I compile this right now. I'm in math mode. It sees the y, the l, the o, the g, the x, thinks those are all variables, so it's going to look funny. I mean, you can understand what it's supposed to be, right? But I do see beginning students doing this a lot in their papers and forgetting to put the backslash in front of the log. Use the backslash, and then you need a space between the g and whatever comes next. And then it will typeset this correctly. So only the variables x and y are italicized and the rest of the equation is not. So there's our common log, y equals log of x. Let's change the base in our log. So if we want log, backslash log, oh, that's supposed to be equal, y equals backslash log. If we want base 5, for example, we need a subscript. So remember how we did subscripts. It's the underscore 5. And then I'm going to type a space. It's not strictly necessary because if I don't use curly brackets, it will only subscript the next digit. But just to be clear, I like to always put a space there like that. So this log, oh, what did I do wrong? Oh, I'm missing a dollar sign, double dollar signs. Okay, log base 5 of x. And then let's do a natural log. Y equals \ln space x. That's going to give us a natural log. Next, let's talk about square roots, and not necessarily square roots. Let's just say roots in general, because we can see how to do cube roots or fifth roots or seventh roots. So we'll just say roots in general. We'll start simple. Square root of 2. So to do a square root, we're going to hit \SQR, and TechMaker is making 2 suggestions for me here. So we can see it's \SQRT, and then we have an option where there's square brackets, curly brackets, or we have an option where it's just curly brackets. If you're just doing the square root of 2, you don't want the square brackets, you just want the curly brackets. So SQRT, curly bracket 2, curly bracket, like so. And that's going to give us the square root of 2. The other option is for when you want roots that are not square roots. So let's do the cube root of 2. You're still going to type \SQRT. So it's like you're starting the square root command even if it's not a square root, but then you're choosing the one that has the square brackets followed by the curly brackets. So I can hit enter here to accept that and then start typing, or I could just keep typing it manually. So here, the square brackets are for the root. If I want a cube root, then I type a 3. The curly brackets are for what goes inside of that radical symbol. So we want the cube root of 2. It's going to look like so. Cube root of 2. Now this one down here is my page number. It's bugging me a little bit. So I'm going to go ahead and turn off the page numbers. And to do that, I'm going to scroll back up. And I am going to, after document class, I'm going to type \page style, curly brackets, empty. And I think that'll take care of that. So let me recompile. And then, yep, our page number is gone. So I'm turning that off just so that's not in our way. Okay, back to more roots. Let's do something more, a little slightly more complicated, like square root of x squared plus y squared. So \square root x squared plus y squared. Okay, looks good. And now let's get a little more complicated and put a square root inside of a square root. So the square root of 1 plus square root of x. So we'll start with the outside root, the square root, oops. Okay, the square root of. Now, once you start putting things inside of other things, it can get a little bit confusing. So what I will sometimes do is just insert some extra spaces, just so it's easy for me to tell what's inside of what, because it's got a little cushion around it. So this is my outside square root, my big square root. And inside of this square root, I'm going to put 1 plus the square root of x. So 1 plus \, square root of x, like so. And compile. And we've got 1 plus, or the square root of 1 plus square root of x. All right, and then finally, let's look at fractions. So we'll start with something really simple. We'll just do the fraction 2/3. So the command is \frac for fractions. And you can see that TechMaker is prompting me. I can hit enter to accept that. And this is in general what it looks like when you want to make a fraction, or if I'm typing it manually. If I'm typing it manually, I usually still do kind of a template thing. So I'll do curly brackets for the numerator and then curly brackets for the denominator. And then I'll just use my cursor and go back in. And that way I don't forget to close my brackets. So you have a pair of curly brackets for the numerator and then the next pair of curly brackets for the denominator. So in the numerator is 2 and in the denominator we want 3. So this should give me the fraction 2/3. Okay, that looks good. Now I'm going to type this in a sentence. So let's just say about. And because I'm typing this in a sentence, I'm not going to use double dollar signs. I'm going to use single dollar signs because I want this to be inline math mode. So my fraction, 2/3. And I did that more quickly using my keyboard because, let me do that one more time and explain. Backslash, okay, so here I just hit enter because TeXmaker is going to populate that for me. And notice it automatically highlighted the numerator. So I type 2 and then I can hit tab on my keyboard and then type the 3. So it goes pretty quick once you get the hang of it like that, rather than just typing it manually. So about 2/3 of the glass is full. And there's that sentence. So the 2/3, it's smaller, obviously, in this sentence than the 2/3 up here. When you're in inline math mode, it's going to resize to fit your sentence, right? You don't want this huge 2/3. But sometimes, like if you're writing a homework problem, quiz, a worksheet, something like that, sometimes your fraction is too small in the sentence here and you do want to make it larger. So easy way to do that is instead of \frac, use \dfrac. The D is going to put it in displayed math mode, dfrac. So now when I compile it, it's going to be, it didn't like that. Oh, I may need a package in order to use that. Okay, let me try this. Let me try this a different way because I haven't talked about packages yet. But packages, we will be using packages soon. Another way to get into displayed math mode is to type \display style. Let's try that. There we go. So now it made the 2/3 bigger, same size as it made it up here. When you use double dollar signs, you're automatically in displayed math mode, and so everything is large like this. If you just do the \frac in inline math mode, it's going to be small. So this looks kind of silly. The 2/3 is really big compared to the rest of the sentence. I don't like that, so I'm going to, well, I'll leave it in here just for tutorial purposes. Let's maybe copy that one more time and take it out. Take out the display style. So you can see a comparison. Now, because I'm not using double dollar signs, it's not automatically creating a new line. So here's where we have to decide how we're going to break that line. Do we want to do a double backslash like that, which will break the line? You can see I'm sort of running into an issue here because the lines are not far enough apart. I can manually add some vertical spacing using square brackets, and then inside the square brackets tell it how much space I want. So 6, and then you can use any unit of measurement here. You can use centimeters. 6 centimeters would obviously be way too big. I usually use PT, point size. So give me 6 points of space at the end of this sentence. And then when we compile, you see it inserted some vertical space there for me. Your other option, if you don't want to break the line that way, would be to leave an empty line in between, and that would also create a line break. We talked about this in the last tutorial though. Notice it looks odd because this new line right here is starting a new paragraph and it's indented versus this line up here did not. This line up here is not indented, so that's why it looks a bit funny there. So I usually, and it just depends on what you need, but I usually do something like this when I want line breaks. And generally, if I want displayed fractions, display style fractions, and rather than typing out display style, I just do \dfrac. But I did get an error when I tried that a moment ago. Let's try it again. Not that I'm expecting anything different. 2/3. And I just have to figure out which package I need to use in order to get that to work properly. So I'm going to go back up to the top and really quickly just figure this out. Use package. And let's go with AMS Math. I'm gonna use a couple packages here because I don't want to do them one at a time and try and figure this out. AMS Math, AMS Sim, and AMS Fonts. Okay, one of those worked because now it did compile correctly. And, oh, that was unnecessary because I had double dollar signs. Let me try that one more time because the double dollar signs automatically put it in displayed math mode, so it's kind of redundant that I used defrac inside of double dollar signs. It's not necessary to do that. Let's just try this again. And verify that we are getting a large fraction here when we use defrac. Yep. And I need a line break there. Okay, so you can accomplish the same thing this way and this way. Let's try a more complicated fraction. So I'm going to do a line break here again. No, I'll go ahead and put it in double dollar signs, so this isn't technically necessary. Let's do this. Let's do a square root inside of our fraction. So let's do the square root of x plus 1 over the square root of x plus 2. So we'll start with fraction. Fraction, like so. In the numerator, we want the square root of x plus 1. So backslash square root, like so, x plus 1. That's my numerator. Then here is my denominator. So we're going to do square root x plus 2. And then close our dollar signs. And there we go. So I did use, Tech Maker to my advantage there. I wasn't typing it all out manually. So let's try that one more time. If I were typing it out manually, backslash frac, your curly bracket, then slash square root. You have to open another curly bracket. So at this time, you have to kind of mentally keep track that you have two curly brackets open, and eventually you need to close the two curly brackets. So x plus 1, close it for the square root, close it for the numerator. Then we open curly brackets for the denominator, backslash square root, open curly bracket for the square root, x plus 2, close the square root, close the denominator, and then close math mode. And there we go. Now, sometimes we work with complex fractions where you have a fraction inside of a fraction. So let's try that. So outside fraction, and let's do 1 over, so just 1 in the numerator, that's it. And then in the denominator, let's do 1 plus 1 over x. So 1 plus, and now I need a fraction. So backslash frac, 1 over x, like so. 1 over 1 plus 1 over x. And you can, of course, have fractions inside of fractions inside of fractions. You just want to pay attention to your brackets, make sure that they're paired. And like I showed you a moment ago, sometimes it is helpful to space things out. So my denominator here had a bunch of stuff in it. You might find it's helpful to kind of leave lots of space in the curly brackets for the denominator so that if you do get a compiling error, you can go back and see that's probably where it would have occurred because you've got, complicated things inside of other things. So that can be helpful as well. That wraps up this tutorial on common math notation. I do have another tutorial on calculus notation, which will be much more involved. There's lots of notation that we use in calculus that we need to use LaTeX for because you can't type a lot of the calculus notation using your keyboard. But in the next tutorial, before we do that, the next tutorial, we're going to look at brackets, tables, and arrays. So brackets include things like parentheses and square brackets and curly brackets and absolute value symbols. We're going to see how to make those things expand in size because if you just type parentheses, let me show you real quick, right here around this, it's going to look really bad. Well, actually, it doesn't look too terrible, but the 1 over x here is longer vertically than the parentheses. So we're going to see how you can fix that, make your parentheses taller so that they do wrap around the content inside of the parentheses. And then we will look at tables. We'll do a simple table, we'll do a slightly more complex table, and then we'll look at some arrays. Hello, I'm Michelle Crummell, and in this video we are going to look at how to typeset brackets, tables, and arrays using LaTeX. I'm working in TeXmaker, but you can work in any text editor that you like, or you can work online in Overleaf. And there are links in the description below to register for an Overleaf account if you want to just work in your web browser. So we have lots of different type of bracketing symbols when we use math notation, but probably the most popular would be parentheses, square brackets, and curly brackets. So let's start there. If you have a short object, then you don't need to do anything special for parentheses. Let's say, for example, the distributive property states that a times, and notice I did use a dollar symbol to enter math mode, a times b plus c equals a times b plus a times c for all a, b, c. I can get fancy here with my notation if I want. I can use the element symbol or the \n. And then if I want to say the set of real numbers, then there's a special way to type that symbol as well, \mathbb, curly brackets, and then for the set of all real numbers, I need a capital R. Now, I think I'm going to have to load a special package to make this work. Let's see if I get a compiling error. I do. Okay, so let's come back up here in my preamble. Everything before begin document is called the preamble, and I'm going to use a package. Let's see, AMS fonts, AMS sim, AMS math. I always load those 3 packages right off the bat, so to be honest with you, I don't even remember which one of the 3 I need. It's only one of those 3 that I need to make this mathbb command work. I'm just so in the habit of using all 3 packages all the time, so I don't remember which one does what. Okay, but that worked, and we can see the result here. The distributive property states, and so here we have this in math mode, a times b plus c. The parentheses look good. They are sized appropriately for what's inside. Equals ab plus ac for all a, b, and c in the set of real numbers. Now square brackets work in a similar way. You can just type them using your keyboard. So let's use a line break here. There's a couple ways to do a line break. I like to do the double backslash and then insert a little bit of extra space. There are lots of other ways to get spacing between your lines, things that you can do in your preambles so that you don't have to do this every single time. You can change the line spacing throughout your whole document, but that's a little more complicated, and we're trying to keep things really simple for right now. So I'm just going to do that. And next we'll say the equivalence class of A, I'm putting A in math mode, is, and then we'll use square brackets around the A there, and I will typeset that. So I'm just using F1 on my keyboard because that's a keyboard shortcut for TeXmaker to compile. Otherwise, I could also come up here and click this arrow. Okay, so the equivalence class of A is A, and you can see the square brackets appear as expected. A is just a normal sized element, so the brackets don't need to be larger, smaller, they're sized appropriately. Okay, this does look a little weird though because the first sentence is indented and the second one is not. This double backslash creates a soft return. It doesn't start a new paragraph, and so this sentence that I have here is not considered a new paragraph and it is not indented. I'm not in the habit of worrying about that because I almost always turn off indenting in my documents. So I'm going to come back up into the preamble. It's the area before begin document. I'm going to type /par indent. This is going to change the rules for paragraph indenting. And I'm going to say 0px. So indent my paragraphs by 0 pixels. In other words, don't indent my paragraphs. And then I'll recompile. And you can see that none of my lines are indented. That's just my preference, the way that I like to work. You certainly don't have to do that. Now let's take a look at curly brackets. So parentheses, easy, you just type them on your keyboard. Square brackets, easy, just type them on your keyboard. Curly brackets, not quite so easy. We'll say the set A is defined to be, and then we'll just call A the set of the numbers 1, 2, 3. So curly bracket, 1, 2, 3, curly bracket, close math mode, and then compile. What did I do wrong here? Forgot my square bracket in front. Let's try that again. Okay. Now, I didn't get the result I expected because I typed curly brackets around this set, but the curly brackets didn't show up on my PDF. And that's because the curly bracket is a symbol that is reserved for part of the coding in LaTeX. That is a special symbol that tells the compiler something. And so you can't just type a curly bracket and get it to show up. You have to do something different. If you want the curly bracket to show up, you type a backslash in front of it. And that's true for this opening curly bracket and also the closing curly bracket. You put a backslash in front of it, and now when we compile, the symbols will show in the PDF. So the compiler knows that this is not the coding curly bracket is actually one that needs to be displayed. Now, another symbol that is reserved for special syntax in LaTeX is the dollar symbol, and we've seen that many times so far. The dollar sign is used to indicate that we're starting math mode, but sometimes you might want to display a dollar sign, right? If we're talking about money. So for example, the movie ticket costs $11.50. Okay, so right away I know that I have a problem here because this has turned green. This has turned green. So the compiler thinks that I've opened math mode and I have not closed math mode. Well, I can close it here, and that's a little better. We're back to normal down here. But now clearly the dollar sign, this dollar sign is not going to be displayed because this is just telling me that I'm in math mode. So let's compile that, and I don't see the dollar sign. So if you want to see a dollar sign, well, first of all, if we type an extra one inside math mode, we're going to have issues. That confuses the compiler. So if you want to display the dollar sign, you just type a backslash in front of it. Same with the curly bracket. And now when we compile, it knows, oh, this dollar sign is meant to be displayed. And so it will print it on our PDF. And we've got $11.50. Now, sometimes you want to put brackets, whether they're parentheses or square brackets or curly brackets, or absolute value symbols or some other symbols, greatest integer symbols, that type of thing. Sometimes you want to put those around notation that is much bigger, taller. So let me show you what I mean by that. And here I'm just going to do a hard return here. And let's type this fraction. I'm going to do double dollar signs to give me displayed math mode. So it's going to put this math on its own line, centered on the page, and I'm going to type a fraction. So my fraction is going to be 1 over x squared minus 1. Here's my fraction, 1 over x squared minus 1. Let's say I want to put parentheses around that. I don't know why, maybe there's a 2 in front of it. Yeah, let's do that. Okay. That looks pretty bad. The parentheses are not tall enough. They're not surrounding the information inside of the parentheses. Now, if I wasn't in displayed math mode, it would be a little better. So instead of double dollar signs, let me go back to single dollar signs and show you. It's a little bit better. It's still not perfect. The parentheses still don't seem to be tall enough to cover what's inside of them. So it's not just because I'm in displayed math mode that that's an issue, but it's more pronounced when you're in displayed math mode. How can we fix that? Well, we can make the parentheses automatically change in size to fit whatever's inside of them by typing, go to your parentheses where they start. So your left parenthesis, I think, is the singular of parentheses. Go to your left parenthesis and type \left in front of it. And then go to the right parenthesis and type \right in front of that one. And now let's compile that. And you can see that they've automatically expanded to an appropriate size. That looks much better. So this works with lots of different bracketing symbols. I'm just going to copy this a couple of times, and we're going to change the parentheses to square brackets. Square bracket, and curly bracket. Now remember, to get the curly bracket to show up, you have to put a \, in front of it. And compile, and there we go. So we've automatically expanded the size of our brackets in these 3 examples. If you're working with vectors, you might even want an angular bracket. So let me delete, I'm just going to space this out a bit. If we want parentheses, we would type parentheses like this. So let's go back to parentheses. Okay, that's normal parentheses. But if you want an angular bracket, instead of parentheses, you're going to type \L angle. So left angle. And then over here, instead of parentheses, you're going to type /R angle. /R angle for right angle. And then when we compile that, you get your angular brackets. You might also need to do this for an absolute value expression. So instead of this left angular bracket, we can just use on the keyboard, type the, I think it's called a pipe, but it's right above the return key or the enter key to get your absolute value symbol to expand. So \left, \right is going to expand the size of those brackets. Now, there might be a case where you just need a bracket to show up on one side, not the other. An example of this could be in calculus. If we have something like dy dx at x = 1, we could use a notation. So let me start with a fraction for the dy dx. So \frac dy dx. And now I want dy dx at x = 1, or when x = 1. So normally the way we write that is we would do a vertical bar and then a subscript. So here's a subscript of x = 1. Now if I just type x = 1, only the x is going to be in the subscript. So I need to put curly brackets around my x = 1 if I want that all in the subscript. Let's see how that looks. So I'm almost there, but that vertical bar, that pipe symbol, it's not tall enough. I want it to expand. So let's try that trick where we type a \left or a \right in front of it. Let's do /right to get it to be larger. Now, when I try and compile this, I'm going to get an error because when you use a /right command, you have to have a matching /left and vice versa. So when you do /left, you need a /right. But I don't want a symbol to show up on the left. We can get around that though. I'm going to go ahead and type the /left. And then in order to tell it to not display a symbol, I'm just going to use a period. Just type a period on your keyboard and it won't display that. So now the notation looks proper. So hopefully that covers all of the types of bracketing symbols that you need, and you can certainly have brackets around something that's inside of something else. So you could have multiple pairs of brackets all in sort of one expression. For example, let's kind of build off of, well, let's do, a fraction. We'll do a complex fraction. So fraction, we'll do 1 over 1 plus x to start with. And let's say we want to put parentheses around that. So we'll do slash left and then the left parenthesis, slash right and the right parenthesis. We'll compile that, so that looks good. And I'm going to put a 1 plus in front of this. Okay, so there we are now. Now I want to make this all the denominator of another fraction. So it'll be 1 over 1 plus 1 over 1 plus x. Okay, so this whole thing that I've typed right here, I want to be in the denominator of a fraction. So I'm going to put curly brackets around it. That's the curly brackets for my denominator. In front of that, I'll do another pair of curly brackets for the numerator, and the numerator is just going to be 1. And in front of that, I need my fraction command. Let's compile that. So there we go. And notice that the parentheses are adjusting in size to fit like the container, what's inside. Now let's say I want to put big parentheses around all of that. So in front, I'll do a slash left. Oh, I'm in the wrong place, sorry. Go to the very front. There we are. Slash left, parentheses, and then go to the very end here, slash right, parentheses, compile. Now you can see those parentheses are really big. So they are automatically going to adjust to the content inside of the parentheses. Okay, let's move on and talk about tables. I'll just give myself some space here. And we will look at tables. We'll start with a very simple table and then we'll add some more components to it. So first of all, to start my table, it's backslash begin curly brackets tabular. Actually, I'm gonna, hit enter and let it kind of finish that out for me. So with a begin tabular, you'll have an end tabular. And notice that we have an extra pair of curly brackets after begin tabular. So here you have to establish like how many columns you want in your table. Let's say we're going to make a table with x values of 1, 2, 3, 4, 5. So we need 6 columns in our table. 6 columns in our table. I can type C, 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 C. I typed a C 6 times. Each one of those C's represents a column. So this is going to be a table with 6 columns. Now the reason I typed a C was not, C doesn't stand for column. C stands for centered, because the text or the whatever it is you're putting in the cell of your table, it can be center aligned, left aligned, or right aligned. So like normally I would say probably your mathematical tables, your values are going to be centered in the table cell. So I normally use C's. If I wanted items in my cells to be left aligned, I could use L's. L, 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 L. That would give me a table with 6 columns. If I wanted the content to be right aligned, I would use R's. You can also do any kind of combination like that. So you identify for each column if you want the content to be aligned left, center, or right. Let's go back to center aligned. And then we have to type some content for our table. So I'm going to type, this is what I want in my table, x, 1, 2, 3, 4, 5. So this is not going to work right now if I compile. Oh, it actually did give me something, but it's not a table. This is just one, this is all in one column right now, all in one column. The way that you separate items into columns is with the ampersand. So now if I compile, X is in the first column, and then right now 1, 2, 3, 4, 5 is in the second column. So we want to go through here and put an ampersand in between like so. Okay, now we have a table with 6 columns, which is what I wanted. I guess it would be easier to see. You just kind of have to trust me right now how many columns I have. It would be easier to see if we had, lines separating. So I should have done that, let me go back and show you how to do that. If you want vertical lines, like in between your table columns, then you come back up here and you use that pipe symbol on your keyboard. It's above the return key or the enter key. And you put that in between each one of these like so. Let's recompile. And we get those vertical bars. So now I can see how many columns I had. So let me take out my ampersands. Let me go back to what it was. 1, 2, 3, 4, like that. And you can see that it was all smushed into one cell, which is not what we wanted. So you need to use the ampersands to separate the content into your different columns. Now, when you get to the end of your first row, you hit 2 backslashes to indicate that that is the end of the row. Okay, so here we are. Then you can do your next line. So the next line, let's say we want f of x and then whatever our f of x values are. We'll just do 10, 11, 12, 10, 11, 12, 13, 14, and we'll end that line. Okay, that's all right. Now the x and the f of x, they don't look like math. They're in text mode, they're not in math mode, so let's fix that. Put dollar symbols, dollar signs around the x and around the f of x. All right, that looks much better. Now we're missing the lines that separate our rows, right? So in order to get a horizontal line, we're going to type \h line. Now we'll compile that and it gives me a horizontal line. So I did that at the end of the first row, and I'm going to do that again at the end of the second row. Now I need to do that above my first row. Okay, and there is a basic table. Sometimes I like to, after the first column, put a double pipe here to separate the label x, f of x from the values in the table, like so. So we can do that. So that is a very basic table right there. Let me copy that. And let's say that instead of 10 for f of 1, we had a fraction here. So we'll do math mode /frac, and we'll just use the fraction 1/2. Oh, let's separate these tables a little better. So I'm going to insert some vertical space here, /v space. And then I can decide how much vertical space. I'm going to put 1 centimeter of space right there. Just to separate those tables. And I'm going to turn off my page numbering as well. So I'm going to go all the way back up to the top, /page style, empty, compile, and that turned off my page numbers. Okay, so there are my tables. Let me scroll back down here. So I'm working with the copy of my first table right here. We changed f of 1 to equal 1/2. And you can see that the 1/2, because it is taller than these other values, is sort of touching the top and the bottom of the row border. We want to give this a little more space. And so let me show you how you can add a little more to this table. Instead of starting with begin tabular, we're actually going to start with /begin table. Now, if I hit enter, it's going to put my end table right here. I need the end table to go after the end tabular. It's like a sandwich, right? We've got begin table, begin tabular. And then at the end, we have end tabular, end table. Okay, so, I mean, that hasn't changed anything yet. Let me recompile. We're still in good shape. Actually, I lost my second table. I think that begin table requires a package. Hang on, let me do full page. I wasn't expecting that to have, oh, okay. Here's the second table up here. Yes. So this is the frustrating thing about working with tables. In a word processor, when you enter a table, you're very specific about where you want that table to appear. It's wherever you type it. Wherever you enter it, that's where it's going to be displayed, right, in a word processor. Not so here. Here, when you enter a table, the compiler is going to decide where it thinks that table will fit best on your page. So you can see what happened to us here. And the second table is the one that had the fraction 1/2 for f of 1. So that's this table at the top here. It got moved up to the top of the page. That's not where I want it. I want it down here at the bottom of the page. And normally you're particular about where you want your table to go. If you're creating a long paper, you might not matter so much whether it's, you know, on the page before or on the next page or at the top of the page or at the bottom of the page. Like, you might be fine with giving the compiler the flexibility to decide where it thinks the table will fit best. There is a way that you can tell it, no, I want it to appear right here in the code where I've entered it. And all we need to do for that is square brackets and a capital H. So let me recompile. And I think I need the float package for this. Let me go back up to the top. / use package float. Yes, I did. We'll talk about packages more in another tutorial, but for certain commands in LaTeX, you need to load a package before the command is going to work. So in order to use this right here, we need to load the float package. All right, so now we're good to go. Let me make this larger again. There's our second table. And we were talking about the spacing issue. Like, I want to add more space in there. So in between begin table and begin tabular, I'm going to type \def. That's going to define something new. And then \array stretch. And then in curly brackets, you're going to type a number. And the number that you type is going to determine how much extra spacing you have. I usually go with 1.2. So let's compile that and see how that looks. So just added a little bit of space, right? You can make that bigger. Like sometimes I'll go up to 1.8. Let's just go with 2 and see what happens. Okay, so if you go with 2, then you get, that's too much space. Like now it's starting to look a little bit weird. Maybe we'll split the difference. We'll go like 1.5. All right, that looks pretty good. It's not perfect, like there's more space at the top than the bottom, so you can play around with that if you don't like exactly how it looks. But that's an easy way to get some extra padding, if you will, in your table cells. The other thing we can do by starting our table with begin table, in addition to the begin tabular, is we can now add a caption to our table. And you can add the caption above your table, or you can add the caption below your table. Let's add it below. And so after the, in between the end tabular and the end table, I'm going to type /caption. And then you can enter your caption. So I don't know what we want to say. These values represent the function f of x. And we'll compile that. And yeah, that looks a little weird because, let me go back to full page. The caption looks like it's being centered, whereas the table is not being centered. So that is a bit strange. If I want my table centered, then again, in between begin table and define and begin tabular, I can do \centering. And that will center the table. I normally center my tables, so I wasn't expecting that issue. I'm not used to that popping up, especially when I'm captioning things. I like normally in my workflow, I center my tables. So I'm sure there is a way to get the caption to go to the left. You can force things to be flushed left if they're not automatically that way. But it's easy. It's an easy fix if you just want everything centered. And there we go. Now there are a lot of other things you can do to create more complex tables. I don't want to spend too much time, but there are some instances where you might want, what's it called? Where you have like something that spans over two table columns. I know there's a word for that. I can't think of it off the top of my head. But you can do something, merging cells, I think is what it's called in a spreadsheet program, where you can merge cells together. So you can do things like that as well with tables. You can also, sometimes you might want to have a sentence in a table cell. That sounds kind of weird, but I could think of an instance. Let's just do one real quick. I'm going to copy this table. So here's a copy of that table, which didn't fit on page 1, so it got pushed down to page 2. We'll make this a little bit bigger. And let's do something where we have just like 2 columns in our table. And I'm going to put text in here. So we might want it centered. We might want it flush left. We'll just see how it goes. I'm doing this off the top of my head. And I only have 2 columns, so it needs to look something more like this. Okay. And we're going to say at the top, f of x. And then in the second column at the top, we'll do f prime of x. And here we'll say x greater than 0. And here we'll say the function f of x is increasing. So let's see what that looks like. So this is a different kind of table. It just doesn't have just numeric values in it. It looks a little bit odd. Let's change the caption too, so this makes a little more sense. We'll say the relationship between f and f prime. Okay, and we could, if we want to this time, move the caption to the top. I noticed that it automatically numbered the tables. I didn't point that out either. It didn't happen with this table because with this really simple table, we just used begin tabular, end tabular. With these next 2 tables, we started with begin table before we did the begin tabular, and that gave us all of these extra options. And one of them is that it will number your tables as you go. So I didn't type table 1. That was this table right here. I did not type table 1 anywhere. It just knows that that is the first table in this begin table sequence. And then this next one, when I began a new table, now it knows, oh, that's table number 2. So it is numbering that for me, which is nice. Okay. What I wanted to show you, though, was how you can deal with long sentences in your table. So I'm going to copy this sentence a couple of times, which isn't very realistic, but let's just say like you had a lot of text to put in your table cell. Okay, then this happens. Let me make this, okay, this looks horrible, right? The table got cut off because the content inside of this one cell is so long, it doesn't fit. And so it ran off the page, which is definitely not good. We don't want that. So an option, if you're trying to type text, like long text in a table, instead of using a C here, and let's go ahead and change these to L's anyway, first, just to show you that when I do that, now in my table, this became left justified instead of centered. All of this became left justified. But what I can do with this instead, this second column, because I know that it has to accommodate such long text, is to put a P, and the P stands for paragraph. So it's indicating that we want this cell to contain a paragraph. And then in curly brackets, you indicate how wide you want that paragraph to be. So maybe we want it to be 2 centimeters. You can use inches. You can use other measurements that you want. Okay, so now at least it fits on the page. It still looks a little funky, right? But you can change this. We could even go with 2 inches, 3 inches. You can adjust it to fit your needs. And you can do that for each column. So if you have multiple columns with a lot of text in it, you can do that. All right, that's the basics of working with tables. There are a lot of other ways to customize tables. You can do shading, you can do all sorts of things, but this will get you through most of what you need to do with tables. We're going to wrap up this video today by talking about equation arrays. And so the easiest way I have found to create arrays is with the align command. Now there is also an equation array command, and by that I mean you can do \begin EQN. You can see right here, begin equation array. You can do it this way, and I used to do it this way, but now I have a different way that I prefer to do it. So I'm going to do let me first of all just say, put a little header here, arrays. And we're going to do \begin align. Now we have 2 options here. We've got a regular align, and then we have an align with an asterisk after it. Let's go with the regular one first, and then I'll explain what the asterisk does. Okay, so begin align, and we have to put some kind of content in here. So let's use this to solve an equation. 5x squared. Now notice when I started typing, this is in green, and green indicates that we're in math mode, but I didn't type a $sign. When you're inside of the align environment, you are automatically in math mode. So if I start typing text, now see the text is still green, that text is actually in math mode. Let me compile and show you, right? This looks really wonky. Everything in align is in math mode. So if you actually want text, you have to have some way to tell it, wait, I don't want this to be math mode. And you can do that with \text, and then just type your text. Let me change the text. Place your words here. Oops, curly bracket. Let's compile that. So now it knows that that's text. And we still have like a spacing issue here. In math mode, this hasn't come up yet, but in math mode, the compiler ignores spaces. Like between the 5 and the X here, I can type as many spaces as I want. They're not going to appear on the document when I compile it. The 5 and the X squared are still right next to each other. So in math mode, spaces get ignored. And that's why this space is being ignored. So the P in this word is right next to the 2. If you need a space, there's a couple things we can do. In the text mode, we can just type a space, and that'll take care of that. So that worked. Or in math mode, if you need to force a space that will be displayed, you do \comma. So either one of those methods will work. Okay, but that's not actually what we're trying to do here. So let me take that out. 5x squared, we're going to solve an equation. 5x squared minus 9 equals x plus 3. So what I want to do next is subtract the x on both sides, subtract the 3 on both sides, and then write the result. Okay, so I need to end this line with a double \. And on the next line, type what I want next. 5x squared minus x minus 12. Oh, equals 0, right? Equals 0. Okay, so that's all right. Notice that I've got my equations on their own lines, and the equations are being numbered. So I didn't have to tell it, this is line number 1, this is line number 2. It's going to number them. And if I create another align, just duplicate this one, and compile it, it continues numbering from where it left off before, which is really nice in a math paper because your equations are all numbered, and then when you're talking about them in your paragraphs, you can refer to them by number. You can say in equation 4, blah, blah, blah. So that is nice there. What I don't like about what I'm seeing, though, is that the equations are not aligned at the equal sign. It's much easier for the reader to follow the mathematics when you're solving an equation or simplifying things. You're going step by step. If you line up your equal signs, that's the proper way to do it. So in order to line up the equal signs, you just have to put an ampersand in front of them. Now, if you only do it on the one and not the other, it doesn't know what it's supposed to be lining up, so that's not going to work. It's going to be funky. But if you put the align in front of both equal signs, it knows to line up those equal signs. And this looks proper. This is what I wanted to see here. And we can, of course, add more lines than this. Just do double backslash and keep going. If you get to the point where there's nothing on the left side of the equal sign, that's okay too. We can just say ampersand equals, and it's going to start with an equal sign and line it up. So I don't know, we could do 12 plus x minus 5x squared, like so. And everything is lined up at the equal sign there. Now, if you don't want the line numbers to appear, not just appear, but if you don't want your lines numbered, that's when you would use the asterisk. If you do it in the begin, you have to also do it in the end. If they don't match, you'll get a compiling error. So this is going to turn off the equation numbering. So when I compile, the 3, 4, and the 5 have disappeared. And then if I copy this one again and compile, you'll see that it picks up where the first numbered one left off. So it's not that it's just hiding the line numbers, it's not even numbering them. So think about that carefully when you use it, which way you prefer to go. Okay, that does it for this tutorial. We looked at lots of ways to use brackets and to customize the height of the brackets. We looked at tables and we looked at arrays. Hello, I'm Michelle Crummell, and in this video I'm going to show you how you can create lists in LaTeX. So we'll be looking at enumerated lists, which are numbered lists, and then also itemized lists, which are bulleted lists. And let's begin by just listing some basic school supplies. So pencil, calculator, ruler, notebook. If I compile now, take a minute to think about what this is going to look like. So pencil, calculator, ruler, notebook. In a word processor, we would see these 4 words, each on their own line, but in LaTeX, we can see that that does not happen. I don't have any line breaks coded here, so the words are just kind of flowing all together on one line. Now, I could insert line breaks, but that's not what I want to do. I'm intending to make a numbered list here. And so let's start over. To create a numbered list, we call this an enumerator list. We start with backslash begin enumerate. And when you have a begin enumerate, you also have to have a matching end enumerate. Okay, so this begins this environment, enumerate environment, but now I have to actually list out all of my items. So then we're going to type backslash item and enter our first item, which was pencil. Hit enter. Now I don't need to do anything to indicate a line break. When I type backslash item again, the compiler knows that this is a new item and it belongs on a new line. So slash item, calculator, slash item, ruler, slash item, notebook. So let's try compiling this again. And now we have our enumerated list. So as simple as that. If we want a bulleted list, then we change from enumerate to itemize. So an itemized list is a bulleted list. And then when we compile that, we see that we have bullets instead of numbers. But I'm going to go back, just undo that, go back to my enumerated list because I want to show you how we can then have like a nested list. So another enumerated list inside of this one. So let's say under notebook, we have several items that we want to keep in our notebook. So I'm going to hit return and I'm going to indent. You can indent just once or twice, however you like it. And this is just kind of to help organize the code and make it easier to find things later if we need to. So I'm going to do a new enumerated list. So I start it with \begin enumerate. And I need to end this enumerate, and you can see how it's indented, and then \item to list my first item. So in my notebook, I have notes, and then we'll do \item homework. We'll say these are the sections in my notebook. /item assessments. And let's compile that and see what that looks like. So we have these sub items, and the compiler automatically indented for us, and instead of numbering it 1, 2, 3, 4, now these are numbered A, B, and C, and you've got the parentheses around the number. So all of the numbering is happening automatically. You don't have to enter any of that manually. Let's do this one more time. Let's see how we can have like another level. And under assessments, we'll say that we have different kinds of assessments. So I'm going to hit enter, I'm going to indent again, and I'm going to start over with another begin enumerate /item to list my first item. So tests, quizzes, journal entries, and we'll compile that. And you'll see how that is now numbered differently as well. Instead of ABC, now it's 1, 2, 3. And if I want to add a fifth item, I just have to figure out where that belongs. So this was item number 1, 2, 3, 4, and the indenting really helps to stay organized, because now if I want a fifth item, I can kind of see where that's going to go. That's going to go right here, /item. And what's another supply that we might need? We'll say highlighters. And that is now number 5. Now there are some things you can do to change the way the numbering appears. Maybe you don't want 1, 2, 3, 4. Maybe you want capital A, capital B, capital C, capital D. Or maybe you don't want the parentheses here. So let's look at a few other options. I'm just going to copy my first list. And let's put some space in between there. With VSpace, we'll do 1 centimeter of space to separate that. And now instead of the default 1, 2, 3, 4, let's say I want capital letters here. In square brackets, I'm going to type it the way that I want it to appear. So I want it like that, capital A and then a period. And let's compile. Okay, so we ran into a compiling error. In order to make this work, we're going to need to load a package. So I'm going to go into my preamble, that's before the begin document, and use package enumerate. Okay, use package enumerate. Now let's come back down here and try this again. And now you can see that that changed that for me. Instead of 1, 2, 3, 4, I've got the A, B, C, D. Now let's try this again. I'm going to copy this here. So I just made a copy. And maybe I don't want it to be like that. Maybe I want it to start out like that. And we can do that. Maybe I want a numbered list, but I don't want it to start with number 1. So here's just kind of the default, really basic list right here. But maybe I don't want it to start with number 1 for whatever reason. Maybe I'm creating a worksheet and on the last page I left off with number 5, and now I want this list to begin with number 6. I'm going to type \set counter enumi and then 6. And you can see that now it started with number 7. So that wasn't actually what I wanted. I forgot that I need to say 5. If I want my list to start at 6, then I need to set the counter's position at 5 so that the next time it sees an item, it will think the last item was number 5, and it'll make the next item it sees number 6. So let's compile this. There we go. That gave me a list starting with number 6. Now let's create this list again. I'm going to go back up and get this first list that I made with all the different levels. We'll add some vertical space here just to separate things out visually. Okay, so this list started over with number 1, and just to make this easier for you guys to see, I'm going to insert a page break here. Instead of this vertical space, we'll do \page break, and that way this new list is on a new page. And instead of an enumerated list, I'm going to change it into an itemized list. Begin itemize, and then I'm just going to copy this and replace all of these enumerates with itemize. So I have a begin and an end 3 times because I have 3 different levels of my list here. And we'll compile that. And I just wanted to show you how this works in a bulleted list. So for the first level, you've got the solid round black bullets. And then for the second level, you've got these dashes. And then the third level, you have the asterisks. Now, sometimes you want to create a list, but maybe you don't want the numbers to show. So let's just copy one of these basic ones. We'll take this one. I'm just going to copy that. Let's add some vertical space here. Okay, and let me take out the customization. And we have just a really basic enumerated list, 1, 2, 3, 4. Let's say for whatever reason, we just don't want these numbers to show. Well, you can simply type square brackets and leave them empty. Don't type anything in the bracket. And then compile. And there's a space there where the number should be, but it's hidden. It's not displayed. Okay, so that's one way around it. You can still have something formatted like a list with all of your items, and then you're not showing any values. You can also customize really however you want this numbering to look. You can do it manually. Now, it's not ideal to number things manually. It's the wonderful thing about LaTeX is that everything does get numbered automatically. So if you come back later and in between calculator and ruler, you want to add pen, it's going to automatically renumber things for you. Whereas if you had manually said 1, 2, 3, 4, now you would have to renumber everything manually after that. So here, if you're okay with taking that risk, you know that you're not gonna, it's not that big of a deal to you, you can do some customization here. Let's say, for example, you wanted this to be an A, but you didn't like the parentheses before and after. You could just do something like that. Let's compile, and we see that it looks like that. You can, I don't know what else you might do here. You can even type words there if you wanted to. You could do one, I don't know why you would do that, but just to point out that you can really customize this. And so these are right justified. So that is one thing to be aware of. It looks a little weird because it's ragged on the left, but if you do these customized labels, they're going to be right justified here. And then your items themselves will be left justified over here. Hello, I'm Michelle Crummell, and in this video I'm going to show you some different ways you can format your text and your document. So for example, we'll be looking at how to make things italicized or bold, how to change the font size, how to create sections and subsections, and organize everything with a table of contents. So let's start with just some basic text formatting. You can change the appearance and the size of your text to some extent. So I'm going to begin by typing a simple sentence. And we'll say this will produce italicized text. So it won't, of course, because I haven't done anything to indicate that I need the text to be italicized. This right now is just producing normal text. But if I want the text to be italicized, let's just italicize the word italicized. Then I'm going to, in front of the word, type \text it curly bracket. Then I begin typing whatever I want in italics, and when I get to the end of the text that I want italicized, I close the curly brackets. So let's compile this now, and we can see that the word italicized has been italicized. So it's that \text it that's going to italicize your text. Let's try making something bold. So this will produce bold text. Now, in order to make your text bold, you use \text BF for boldface font. So we'll say boldface. Is it face or faced? I don't know, but it will be bold. And let's do small caps. This will produce, so for small caps, it's \text SC curly bracket. So we'll say small caps, end your curly brackets, and we'll compile that, and we'll see that we have small caps. And we can also do, this will produce typewriter font. So \text TT, nope, TT. So there's 3 T's there, it's text TT. Typewriter font text. So that typewriter font, you might be wondering why anyone would want to use that, but it is like monospaced, so it's good in certain situations. It's also, I think, good for URLs to make them look a little bit different than the rest of the text. You can offset something like saying, please visit Michelle Crummel's website at, and then I can do my \text TT curly bracket, we're opening our bracket, and then it's http://michellecrummel.com. And you can see that it just sets the text apart. Now, if I were actually doing a hyperlink, this isn't the way I would do it, because we can load a package that will make this link clickable, which would be even nice. You can use the hyperref package for that. I guess since I brought it up, I'll go ahead and show you. So we go into our preamble, which is before the begin document, after the document class, and we're going to do use package hyperref. Okay, that, and then instead of this \text TT, I can just do URL, and let's compile that. And now I have a clickable URL, and you can see that it automatically put that in the typewriter font. I didn't have to tell it to do that. That's just part of the hyperref package. It's doing that. And so now if I click on that in my PDF, is going to take you to my website. You can also customize this even more, because sometimes websites are really long and ugly. So you can do \href and then the URL, but then you need another set of curly brackets, and that's the text that you want displayed. So maybe I'll just say my website, and we'll compile that. And now when you click on the words my website, oh, it didn't work. Oh, it did work. It just didn't give me the little gloved hand icon. Okay, so it did work when I clicked on it. So those are some of the things you can do to change the way that you're displaying your text. We can also change our text size. So let's play with the sentence, please excuse my dear Aunt Sally, which most math students are familiar with, right? Order of operations, parentheses, exponents. What is the M? Multiplication. Yes, parentheses, exponents, multiplication, division. Wait, what's the A? Addition, subtraction. There we go. It's been a while. Sorry. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay. Please excuse my dear Aunt Sally. So let's compile this just so we can see what we're comparing this to. And let me give myself some vertical separation here. /v space. I'll just do 1 centimeter of vertical space there to separate it from the work that we did before. And we are going to make Dear Aunt Sally change size. Okay, so let me copy this. I'm going to paste it several times. And this first time, I'm going to make Dear Aunt Sally large, really large. So to do that, there's a couple of ways I can do that. Let's start this way. \begin, large with a capital L, and then the text that you want large. I don't know, should we include the period or not include the period? I guess we will not. And then \end, large with a capital L. They have to match. Remember, whenever you do a begin, you're going to have to matching end. So let's compile that and see what we've got. So just the Dear Aunt Sally part of that sentence. Let me zoom in here so we can see this better. It did get larger. You know what? I should have started even larger because we can go larger. I'm going to copy this and try this with a lowercase l instead, which should not be quite as large as the large with the capital L. So now we're going to have normal, a little bit larger, and then a lot larger. There we go. And we can make this even larger if we change large to huge. Okay, and we can make that even larger if we change the lowercase h to a capital H. And you can see that that got even larger. Now we can go in the other direction and make things smaller. Let's go back to just normal. And we'll go a little bit smaller than normal. So normal, you could also call it normal size. So sometimes you need that if you have like your whole document is large, but then you want one part of it to go back to regular size. Let's do that. I'll show you that. So you would just do normal size, all smushed together as one word. Okay, so that's the same as this line. Oops. This line right here, the first one. Okay, so let's go a little bit smaller than normal size. And that's going to be script size. And we can go even smaller than that. And go, I think I missed small. I did. We missed small. So let's put small in here. Script size is smaller than small, and I'm trying to do this in a logical way. So normal size, and then if you want it a little bit smaller, you can go to small. And then if you want a little bit smaller than that, you can go to script size. And if you need it even smaller than that, we'll go to tiny. And let's compile that and see what we've got. There we go. So progressively larger and then progressively smaller, all the way down to tiny. Now we can also change how our text is justified. So sometimes you want your text to be centered. Sometimes you want it left justified. Sometimes you want it right justified. So add in some vertical space for this new section here. And let's do centered text. So for centered text, begin, center. And we're of course going to need an end center as well. Then everything you put in between begin center and end center will be centered. So this line is centered. And I could do all of that on one line. Let's save some space. So we can do something similar. I'm going to copy that 2 more times. Instead of center, we can do flush left. So we need to begin and end. Or we can do flush right. Okay, so then we can see our text. Let me zoom out a little bit. This line is centered. This line is, oh, I should change that, is left justified. This one is right justified. That makes more sense. All right, so the begin and the end is a nice way to do this with either changing the font size or changing the way that it is justified, because it's just easy to see where that starts and where it stops. It's very definitive, like where that ends. It's not the only way you can do it. Let me copy these sentences here and show you a different way. And this would work not just with the justification, but also with sizing as well. If you do backslash centering, now notice I don't have a begin and an end. If I do backslash centering, it's going to affect everything that comes afterwards. So all of those lines are going to be centered. If I were to do backslash large, let's say, for example, then everything that comes after that is going to be large. I don't know what's going on with the, that's weird. Why is it? Oh, I see. This is indented. All right. I thought maybe it was like weirdly centered in one part of the page. Nope, this is just indented. That's all that's going on because I did soft returns here. There we go. They're all indented now. Okay, so if we change this to tiny, then everything after that becomes tiny. So it just depends what you want to do. If you want to change your whole document, then you can do this. Something like this is very simple. I usually like the begin and the end, again, because then when I'm going back and looking at my code, it's very easy to see where that started and where it ended. So that's what I've got for text formatting. Now let's talk a little more about document formatting. If you want to create a little title section at the top of your document, then you're going to come into your preamble. So before the begin document, you're going to come up here and you're going to enter 3 different lines. Backslash title with curly brackets, backslash author with curly brackets, backslash date with curly brackets. Now you don't have to type anything in the curly brackets, but obviously if you want your title to show, then you would type something. Let me do a full page view here so we can see what's going on. So let's just say for my title, I'm going to write my LaTeX document. And for author, I'm going to put my name, Michelle Crummell. And for the date, I have a couple of options. I can manually type the date. What is today's date? Hang on, let me check. Sunday, July 26th. Okay, so I could say July 26, 2020, like so. Now I'm going to compile. And notice nothing changed on the PDF. My title is not showing up. So I've entered the needed information to create the title, but I haven't actually told the compiler to print the title in my PDF, to make it. We have to actually tell it to make the title. So after begin document, you're going to type \make title, all one word, and we'll compile, and now I have a title. So there's a couple of things I want to point out. With the date, if you want to manually enter the date, you can. I can change that to anything I want, any text I want, even if it's not a date. If you just want to put some other kind of text there, you can. And you can still use the \date command to do that. Oftentimes what I will do for the date is \today. And then when each time I compile, it'll figure out what is today's date, and then it'll display that date. So if I come back, make some edits, compile this again later, it'll always have the most current date on it. My students don't always like to do that because sometimes they turn in things late and they don't want me to know that they compiled it late. The other thing I want to fix here is the word LaTeX, my LaTeX document. So the word LaTeX is normally typeset in a very special way. And to accomplish that, you have to do \, and then you type LaTeX, and it needs to be done like so, with a capital L, a lowercase a capital T, lowercase e, capital X. And then when we compile, you'll see that it did change like the font and spacing and formatting of that LaTeX. Let me zoom in, because it doesn't look quite right because there's no space between the letter chi and the letter D. So I can create that space by typing another \, at the end of that word and compiling it again. And now we get the space between the chi and the D. So that is a basic little title section on your first page. There's lots of other ways to create title pages that then wouldn't have other things on them, but we'll get into that in another tutorial, how to format a math paper. What we want to do here next is to create some sections and subsections in our document. So let me go to the end here, but before my end document, and create a section. So my first section, I'm going to hit \, section, and then in curly brackets type the name of your section, or the title for your section. So this will be linear functions. That's my first section. I'll compile that, and you can see that there's some automatic formatting that happened to that. That's not like normal text, linear functions. For my section here, it's bold, it's a larger font size, and it's numbered. And I didn't manually number it, the compiler will number it. And so if I create another section, let's create another section and call it quadratic functions. Compile, and now that's section number 2. We can create subsections. So underneath section 1, I'm going to indent, again, just for my own organization. It's not absolutely necessary. I'm going to type \, subsection, curly bracket. We'll say slope, intercept, form. And then let's do another one, \, subsection, standard form. And one more, / subsection, point slope form. Let's compile that. So now we have subsections, and the subsections, again, are formatted in a special way, and they're numbered, 1.1, 1.2, 1.3. If you don't like the way that the numbering scheme looks, you can change that. You can also add subsections. So under our first subsection, let's indent and do \, subsection. Example 1. And one more, subsection, example 2. And compile. And now we see those subsections are labeled 1.1.1, 1.1.2. Okay, let's add a couple subsections under quadratic functions. And the reason I'm doing this is because we are going to build a table of contents, so I want to have enough to fill out my table of contents. So subsection, here we'll do vertex form. Standard form. And factored form. And compile. Okay, there we go. Now, if you don't want the numbering to be displayed, then you type an asterisk after the word section. So if I don't want those section titles to have numbers in front of them, I can suppress that. Same with the subsections. I can do asterisks and hide those. We'll just hide a couple of those. Okay, so you can decide if you want them numbered or not. I'm going to undo that because I do want them numbered for my table of contents. Okay, so here we are. I'm going to go back up to the top of the document, and let's say the very first thing we want after begin document is our table of contents. So backslash table of contents, all one word, compile. And let me go full page. Now the contents is blank. That's going to happen because it requires 2 compilings in order to create the table of contents. So don't panic if you don't see your table of contents. Once you compile, just compile again. So let's compile one more time. And there it is, our table of contents, formatted very nicely with our page numbers. Hello, I'm Michelle Crummell, and in this video we are going to look at packages, macros, and graphics. Let's start by saving our file. So I have a file that I've already started, and I am just going to save that as tutorial 6. So let me find the folder where I want to save that. Tutorial 6. And if we look at that folder here, we can see that it is tutorial06.tech. And we're going to start by looking at some packages that we can use to change how this document looks. Packages are used to load special instructions for the compiler. So you can do things like add features that aren't included in the standard distribution or modify the standard rules for fonts and document formatting. If you want to use a package, you place it in the preamble. So the preamble is the section of code between document class and begin document. So I'm going to come up here to line number 2 and just hit enter a few times to give myself some space, and we can start entering the packages that we want to use. So the first package I'm going to show you is one that I use in almost every document I create, and that is going to affect the size of the margins for my output document. If you'll notice, and I'm going to change the zoom here so that we can see the entire page. There's a lot of white space at the top and on the left and on the right and even at the bottom below the page number. So this is just the default margins that are set here, and normally these margins are too large for the kinds of documents that I'm creating. I prefer to have about a 1-inch margin. So we can use a package to deal with that. Now the easiest way, if I just want 1-inch margins on all sides, is to use a package called full page. To use a package, we're going to type backslash use package. I'm going to choose the option with the curly brackets, and then I'm going to type the name of the package inside of the curly brackets. So it's just full page. And then I'm going to compile. So we can come up here to compile, or I can just hit F2 as a keyboard shortcut. So notice what happened. Now we've got a 1-inch margin at the top, at the left, at the bottom, and let's go back to full page view. And you can see we also now have decreased that margin at the bottom. So that's just really quick, easy package to use if you want 1-inch margins on all sides. Now you can use different size papers. In the United States, typically we use paper that is 8.5 inches by 11. And if you want to make sure you are set up for that, you can come up here and type letter paper to make sure we're using letter paper. If you are using A4 size paper, you can type A4 paper up here. And when I compile, I don't know if you noticed that it went pretty quick. There was only a very slight difference, but look at the bottom of the page here. That did make quite a difference. So let me go back to letter paper. And that's going to give me that 8.5 by 11 size paper. Now, I might not want 1-inch margins on all sides. We can customize this further if we use a different package. So instead of the full page package, I'm going to use the geometry package. And this is the one that I use when I create all of my documents, just because it does give me some more control. So the geometry package, I think if I compile right now, it's not going to do anything. I haven't really told it what I want it to do. Yeah, it looks like maybe it just went back to the default. Let's zoom in here a little bit. Now I'm just fit to page width here. And we can come in front of those curly brackets and put square brackets, and that is where I'm going to enter the options that I want to use with this package. So if I do want 1-inch margins, I'm going to type margin equals 1 inch and compile. F1 to compile. I may have said F2 earlier. I don't remember. F1 to compile. And now I have 1-inch margin. So this really has the same effect as that full page package when I do it like this and just say, give me 1-inch margins all the way around. Although it looks like we don't have a whole lot of space under the page number there. I can make this really specific and say, no, I want the top to be 1 inch and the bottom to be 1 inch, but the left to be 0.5 inches and the right to equal 0.5 inches. And let's compile that. And now you can see that I do have those larger margins on the top and bottom compared to what I have on the left and right. Okay, now my margins are a little bit too small for my taste, so I might change that. And you certainly don't have to use inches. You can use centimeters. You can use any valid measurement that LaTeX will accept here. Okay, typically I just use 1 inch, but we will leave that like so for now. And let's talk about another package. Actually, before we move away from the geometry package, you can also explicitly specify your paper size. So let me just show you that real quick. We could say paper width equals 8.5 inches if we're working with 8.5 by 11, and then we can say paper height equals 11 inches. Okay, so if I did want to change the size of my output for my paper, I don't know, maybe I want to do something crazy like 5 by 7. And then we can see what happens. So when you print this, it's going to print 5 by 7 instead of now 8.5 by 11. So there might be some applications for that if you're making flashcards, for example, and you want them to be smaller, then you could adjust that paper size. Even if your actual paper is not that size, it would restrict the output to that size for you. Okay, so let's just go back. This is bugging me just because it's not what I like to use. Okay, there we go. That's making me feel more comfortable. I've got 1 inch margins all around. Okay, let's talk about another package. And sometimes you're trying to type mathematical notation. Maybe you're looking up some syntax to do something like the symbol for the set of all real numbers, and you try and type the code and then you get some kind of error. Well, that actually requires a package. So I'm going to do use package. And the name of the package that we're going to want to use for that is AMS fonts. That package is going to allow us to use some specialized math notation. So let me come over here to my questions and then add in before question number 1. Let's just say we want something to do with all real numbers. I'm just going to type, this is the symbol for all real numbers. And the code for that, we have to be in math mode. We're going to do \mathbb. You can see that it's popping up as a suggestion for me here. And then we're just going to put a capital R, close math mode, and compile. And I will zoom in over here so we can get a better view of that. But now we have there the symbol, oh, I misspelled symbol, the symbol for all real numbers. And we, of course, have other symbols that we can use, like the symbol for the set of integers. So let me just copy that. The symbol for, and I probably should say for the set of, yeah, let's do that properly. For the set of integers. And that is going to be the capital Z. And we can see that it produces that symbol for us there. We might want the set of rational numbers. And that would be a Q. You get the idea. Now, if I didn't have this package loaded, I'm going to remove that and compile, and you'll see that I get an error. It's looking for, when you see this undefined control sequence, it doesn't recognize that command. We do need to load a package. I don't know if it tells me in the error message that which package I need, but sometimes you will encounter that. So we want to make sure that we're using that package. And whenever I'm creating a document, I automatically load the AMS fonts package, whether I need it or not, because I never know when I'm going to end up typing some mathematical, symbol that might require it. And if you are not including any options, so you're not using the square brackets to define any specific options, then you can actually load multiple packages all using one command. So here I can type, for example, AMS fonts, comma, and then the name of another package that I want to use. So I typically will load AMS fonts, AMS sim, and what's the other one? AMS math, I think. Those three, I just always, when I start my documents, I load those 3 packages, just in case I end up needing them. And, in the end, if you comment that out and compile and everything looks fine, you didn't really need those packages, you can always just leave it commented out, or you can delete it from your code. But I always just keep it in. It's not harming anything. All right. So you load your packages again in the preamble. That is before the \begin document. Now you can also load some macros in your preamble. So macros are used to define your own custom LaTeX commands. And there are a few macros that I use often that I'm going to share with you. But before I do that, let's just, look at how a macro might work in general. So let's say you're working on a document and there's a little snippet of code that you know that you're going to use multiple times in your document. You can define it once using a custom LaTeX command, and then within the body of your document, whenever you want to call that up, you can just type that, command that you've created instead of having to type the whole code. So, for example, let's just say we were typing a paper and we knew that we were going to be working with a rational function and having to type it several times throughout the document. So let's just say that function is y equals, and then we've got the fraction x over 3x squared plus x plus 1. Okay, now I'm in the preamble right now, so compiling will probably give me an error. Like, it doesn't make sense to have this up here. I don't know that I've ever tried doing that before. Yeah, I did get an error because I'm trying to type this before my begin document. It doesn't like that. But I just wanted to establish that this is an equation. In fact, let's move it on down here just so we can take a look at it on our document. doesn't look that great at the moment. If I want that to be a larger fraction, I can go with dfrac instead. And it would look more like that. Okay, so let's go ahead and set up our macro. And all we have to do is type \def for define. We are going to define a new command. What do we want to call our rational function? Maybe we'll just call it \eq1 for equation 1. So we're defining equation 1. And then in curly brackets, you're going to type the code that you want the compiler to run every time you type \eq1 inside of your document. So you're going to have to decide if you want to include the dollar signs as part of the command or exclude them. I would say it's safer to exclude them just in case you're in a situation. For example, if you're doing an equation array or you're in a begin a line environment where you don't want to use dollar signs, you might run into issues there. So I am going to omit the dollar signs and just type the actual equation part there. Now, when we do want to call up this function within our document, we're going to have to type the dollar signs. So again, you can decide if you want to include the dollar signs or not as part of the way that you have defined this special command /eq1. So now that it's defined, we can use it. And it didn't look great just sitting there above critical thinking questions. Let's just make this a new item in our list here. Let's examine the function \eq1. Now again, this is going to be problematic because it's going to try and display equation 1, but it's not in math mode. So you can see if I compile, it doesn't like that. It's telling me I can see right away, oh, you're missing a dollar sign. So we just have to put dollar signs around our EQ1 and we should be good to go. There we are. Let's examine the function. So without having to retype the equation, I can just call it up like this. And then at any point throughout my document, I can call that up again quickly, just using /eq1. So that can be helpful. Let me show you some of the macros that I commonly use in my documents. I have this document open right here. This is one that I use very frequently. And this one, again, we're in the preamble is where we're defining these custom commands. So this one starts \new command, and then the name of the command in curly brackets. So this is the actual command that if I were not using a macro, I would just type this out within the body of the document whenever I want to use it. And this is going to increase the vertical space between items in my list. So it's adding more separation, if you want to think of it that way, the item sep. It's adding separation between list items. And this #1 is where I am going to input a value. So each time this one is a little bit different because it's not a static command that is going to be the same every single time. This one, I have to enter a value when I use this command. And this is the part in the code that's telling me that I'm going to enter a value right here where typically a number would be. So how do we use that? After my begin enumerate, if I decide that I want more space between my list items, I can just bring up this command and I'm going to just type \set like this, \set, and then in curly brackets, I'm going to type how much space I want. So I can type the number 1 here, let's compile, and that has added some space. If I want more space, I could type the number 2. And that gave me even more space. Let's just really exaggerate it. I'm going to type the number 5, and that's giving me a lot of space. Typically, I normally just stick with about 1.2. That's my go-to, unless I'm trying to leave room. Maybe if I'm typing a quiz, I want to leave room for students to write answers, although I typically do that with a vfill rather than the set command. So that is one that I use often. Another one that I use often, let's go over here. Let's look at this one. Now this one is going to require, I believe, that we use a certain package. Yeah, we're going to have to use our packages. You can see I have a lot more packages loaded in this sample document than the one we're working in right now. But let me go ahead. Our commands go in the preamble. So I'm going to put that one up here. And this one is going to insert a calculator symbol. The command that I would be typing is just /calculator. But we are going to want to use these two packages, TXC PGF plots. So I'll come back up here where I've loaded all of my packages, and let's compile. Oh, I haven't actually asked it to use that command, so let's try using it and make sure it works. So I'm just going to right here, let's say I want to let people know that this is a calculator active question. I can type /calculator, compile, and then it's going to insert that little calculator symbol. Now I need a space between that and so I always just put an extra backslash like so, and that's going to give me that little extra space that I need there. And so if I'm typing up a set of homework problems, then my students know that they can use a calculator on that particular question. So that is a really great use of this macro, because I don't want to have to type this code every single time I want to insert that calculator icon. I just do it once in the preamble, and then whenever I want to use it, I can just type the /calculator. So that's how you do custom commands in LaTeX. Okay, and then the last thing we're going to talk about here is inserting graphics. Now it's important when you insert graphics, and by graphics I mean image files. JPEGs, PNGs are typically the ones that you're going to be working with. It's important that you save those image files in the same folder where you've saved your text file. So let me open my Finder window. This is the folder where I've saved my text file. This is the text file we are working on right now. It is in this folder, LaTeX Tutorial 6, Packages, Macros, and Graphics. So I'm going to find the image that I want to use. I've saved it to my desktops to make it easy to find. It's right here. So I'm going to copy that, and then I will come back here. This is the folder where my text file is, and I'm going to paste that image file in this folder. They need to be in the same folder for the compiler to find the image, otherwise you will get a compiling error. So let's go back up top, because we do need to load a package in order to insert images. So the package that we're going to use package, graphic X. Graphic X, that is the package that we are going to use. And then where I want to insert my image, let me go back to a page width view here. Let's put the image right above question number 1 here, or statement number 1 here. We'll put it before the enumerated list. So in between critical thinking questions, I'm going to insert my image right here. And the most basic way to insert this image, /include graphics, you can see that the suggestion is popping up. The scale, now I can go with a scale of 1. I find that typically scale of 1, it sounds like it should be the right size, right? Because it's 100% scale, but it's usually really big. So if I do use scale, I find that I normally have to use a number between 0 and 1, but we'll just try it and see what happens. So scale equals 1, and then you type the name of your file. So let me go back to that folder because I've forgotten the name of it. So the file is limit.png. So here I'm going to type limit. I don't have to type the .png. You can, it's fine, but you don't have to. You can omit the dot and then the file extension. So if I had a limit.jpg file, I could also just type limit. And let's compile. And there is our image. So it is bigger than what I would like for this document. You can see the font size here on the axes is a whole lot bigger than what I have in the rest of the document. So we can decrease the scale, maybe try 0.8. Still too big. Let's go with 0.6. I typically don't use scale. I typically want to make sure that all of my images have a consistent width or maybe a consistent height. So there is another option for sizing your image besides using scale. You can specify the height of your image. You can specify the width of your image. So let's just do width equals, and we will try 5 inches. Okay, so that's pretty big. I don't know why I went with that big. Let's try 3.5 inches. Now you can also specify the height instead of the width or at the same time. So if you change the aspect ratio, things are going to look a little wonky. Let's try height equals 5 inches. And you'll see that I haven't maintained that aspect ratio. So typically I just do one or the other, either width or height. You don't have to use inches. You can use centimeters. You can also use percents. So we could say something like width equals, to do a percent, you want to do something like this. If we want 50%, we could say 0.5 / text width. So that's going to make the width of the image half of the text width. Yeah, that looks about half, right? If I went with 0.75, that's going to be really big because it's going to take up 3/4 of the, I can't say page width because it's not including the margins, but the text width, right? So that's another way that you can size your images there. And if you want something smaller, now it's only 1/4 of the text width. Now, if you want the image to be centered, let's go back to point 4. If you want your image to be centered, and this is the way that you're inserting your image, then before the image, we can do \begin center. And after the image, \end center. We don't want to center everything on the page. We just want to center the image. Okay, so that is a really simple way to get graphics into your document. There's nothing fancy here. We don't have a caption, labels, any of that kind of stuff. So if you do want to have a little more control, maybe you want to add a caption to your image, or you want to have a little more control over the placement of your image, then we can put our image inside of the figure environment. So let me take away begin and end center because there's a better way to do that. If we, right before the image, \begin figure, and then right after the image, \end figure. All right, let's compile that. And you'll see that it moved the image. Now in the code, I've placed the image between critical thinking questions and my enumerated list. But the compiler moved the image and it displayed it at the top of the page. Well, if you don't like that, you have some options for telling it where to place the image. Here we can do in square brackets, an H for here. Place the image here. Now that might not always work because sometimes the compiler thinks it knows better about where that image would fit best. Like if there's not quite enough space where you want to put it, or honestly, I don't know how it decides exactly where to place the images, but sometimes even this lowercase h doesn't work. If you want it at the top of the page, you can use a T. If you want to place the image at the bottom of the page, you can use a B. That moved it down to the bottom of the page. But normally I want my image to be right where I coded it, and so I use a capital H. But if I try and compile this, I'm going to get an error because the capital H requires a special package. And that is the float package. So that is one that I almost always load in my documents in case I need it, because it is also really useful for placing tables, not just images, but also tables. And so if you load that float package and you use the capital H here, it will put the image right where you have the code for the image, regardless of whether it fits well in that space or not. And if you want to center your image, then inside of that figure environment, you can just type /centering. So that will center the image and also the caption if you use a caption. So if we want to place a caption below the image, I can end my line here and type \caption, and then in the curly brackets, type my caption. So this is a visual, or let's just say this, the squeeze theorem. Now notice all I said was caption the squeeze theorem. I never typed figure 1, but look, when it displayed the caption, it labeled or numbered this figure for me automatically, which is really nice. If you have several images in your paper, it's going to number them as you go, and then later if you go back and insert another image, it will automatically, reset all of the numbering and number everything appropriately. Now for those of you who are using Overleaf, let's talk about how to insert an image here. So I've just copied and pasted the code from my TeXmaker file over here, and when I hit compile, I did get a compiling error. It looks like I have 2 errors, and it's because it can't find the image I've asked it to include in the document. So it's looking for this file called limit, and it can't find it because I have not uploaded it here into Overleaf. So you're going to want it to appear in this list along with your TeX file. So here's our main TeX file. I can rename this if I want so that it matches the other one, tutorial 06. So you don't want to always have main.tex be your file names here, because then when you start exporting things to your computer, you'll have multiple TeX files that all have the same name. So I do like, if you're using Overleaf, get it in the habit of renaming those files. Okay, so we need to upload an image and place it here in this list. So here is the icon to upload, and then you're going to find that image on your computer. You can drag and drop it into the box. I have that image on my desktop, so let me do that. I'm just going to drag it over here and drop it, and it appears right here. So now when I compile, it should work out. Okay, and there we go. There is my image. I had no problems finding that file because it is, again, in the same folder here, in the same directory as the TeX file itself. So that does it for this tutorial. We talked about loading packages. We looked at defining some custom commands, and then how to deal with inserting images into our documents. I'm Michelle Crummell, and in this video, we are going to take a look at errors and debugging. So for errors, I have intentionally made some very common errors, and we're going to go through them one by one and see if we can fix them. So I haven't tried compiling this document yet. I'm going to go ahead and compile it. And when I do that, I run into an error. So I'm not actually seeing PDF output produced over here. The file will not compile. And so I have a number of errors, and I can see in my log down here, I can scroll through, I have all kinds of errors. And it's telling me, it's giving me some clues as to where these errors are and then what types of errors they are. So having the line numbers is very helpful. And if you're not seeing your line numbers appear here, you can go into your TeXmaker preferences and make sure you have line numbering turned on in your editor. So that is a checkbox right here that you can select or deselect. But I like having the line numbers show because it really does help when you're trying to find errors. Okay, so let's look at that again. Now, the first error apparently is occurring on line 5, and that's where my cursor is at the moment. So it kind of worked its way through the file while it was trying to compile. And there's a problem here on line 5. So the first thing I like to do is just read it very carefully and see if anything jumps out at me, and I can, sometimes I'll just notice, oh, I see the mistake that I made there. We're starting with double dollar signs, we're closing with double dollar signs. That's not an issue. I have my left parentheses. Now, whenever you use a /left, you need a matching /right, and I'm noticing I don't have a /right, so that's probably the issue. And if we read the actual error, it says right here, missing /right. So that's a big clue to me to let me know what kind of mistake it is I'm dealing with. So I do have clothing parentheses or parenthesis right here, but I did not type /right in front of it. Okay, so I'm going to try compiling again to see if that fixed the error. Now, it still did not successfully compile, but that's because there are other errors in the document. I can tell that I've fixed the error in line 5 because now when I look down at my error log, the first error is occurring on line 8. So we fixed the problem in line 5. Now let's deal with line 8. Notice we don't actually have any code in line 8. So when that happens, I usually go to the line right before it and look for an error there. Another good tip when you're trying to troubleshoot here or debug your code, if there are too many errors or you're just not sure exactly where their error is, you can have the compiler temporarily ignore part of your code by commenting it out. So anything you want to comment out, you can type a % symbol in front of it. Notice that this turned gray, the line turned gray. The compiler is going to completely ignore everything on line 9. So sometimes you'll want to use that strategy just to narrow down where the error is. Now the log says it's on line 8. I know it's not actually on line 8. So what I'm going to do, just to show you how you can use this commenting thing, I'm going to comment everything out except for end document. I don't want to comment that out because we have a begin document. We need an end document or it's never going to compile. So I highlighted everything else here, and I can go individually and type % symbols, but there is a keyboard shortcut. I can type Command T on my Mac, and that will comment all of the lines that I've highlighted. Alternatively, you can come up here to Edit and choose Comment, and it will do the same thing. Now I've just done it twice, so I'm going to, I think if I undo, it'll only do one line. So let me do Edit and Uncomment to, okay, there we go. So now the only code that is going to run when I compile is the lines that are not grayed out here. And I know that I fixed the error in line 5, so let's see what happens. Okay, now it's just giving me errors on line 8, supposedly line 8, but I know for sure that it's happening right here because everything after that is being ignored and everything before that we have fixed. So let's take a look at this and see if we can pinpoint what's missing. The dollar signs look okay. A lot of times there's a missing dollar sign, and that's a common error that you can make. But I'm noticing, you know, for every opening dollar sign, I have closing dollar sign, so that's good. /frac. I've got curly brackets around the numerator. But I don't have curly brackets around the numerator because I accidentally typed parentheses here instead of the curly bracket. So let's change that to a curly bracket. Now I think I've fixed it, so I'm going to try compiling again. And success. The file did compile. Now I've hidden all this other stuff, so it's not showing. So what I can do now is just unhide these lines one at a time. I can uncomment them and back and then try and compile. And we have an error now on line 9. If I look at the error, it says missing curly bracket. So that's probably what the problem is. And sometimes I will count. This is open number 1, open number 2, close number 1, open number 3, closed number 2. Oh, what did I just do there? Here we go. Let's try that again. Actually, when I'm doing this, because it's hard to kind of keep track, I'll count all the open curly brackets and then all the closing curly brackets. So I have open 1, 2, 3. I have 3 opening ones, and then let's look for the closing ones. I've got 1 and then 2. So I know that I'm missing a curly bracket somewhere. Now notice the color coding that's going on to help me. If I put my cursor right after a closing curly bracket, it shows me the pair. It shows me the one that's opening and then being closed by this bracket. So that pair is good. This pair is good. When I click here, nothing got highlighted. Like up here, if I put my cursor next to that, it's going to highlight the pair. But when I put my cursor here, it's not highlighting a pair. So this opening one right here is missing a closing one. So then you're going to look at your code and see, okay, where does the square root end? And that means I have to put 1 at the end right here. And now I've got that pair highlighted. So let's compile and see if that worked. That did work. So that was successful. Let me go ahead and zoom in here. Okay, so now I'm not going to just uncomment begin enumerate because that would certainly give me an error. Whenever you have a begin, you need an end. Okay, but now I think I might get an error here because I'm saying, hey, I'm making an enumerated list, but then I didn't put any items in my list. So you need at least one item. And if we compile, that works. There's my first item. So I'm just going to take a chance. Maybe there's no errors in here. And I'm going to highlight all of this, and to uncomment them all back, I can hit Command U on my keyboard, or I could have gone up here to edit uncomment and it would have the same effect. And now we will compile that, and I am getting an error. So I know there's an error somewhere here. Okay, so let's see if we can figure out what it is. We've got the second item, that looks fine. Begin enumerate, and anytime you see begin something, ask yourself, do you have a matching end? And I don't, because the end enumerate right here matches the begin enumerate right here. So this begin enumerate does not have an end enumerate. So I need to come down right here and add an end enumerate. That's a common error that happens, especially when you're making nested lists. And now everything is okay. Indenting can help with this. If you don't indent and you have everything like this, then it's hard to see which begin enumerate is paired with which end enumerate. It's a lot easier if you indent, and you can indent a bunch of lines at once if you highlight them. And then for my Mac, it's Command Shift and then the right angular bracket on the keyboard, the one where you same key you hit for a period. And you can do that multiple times if you want to indent more. And if you want to go in the other direction, you can use the left angular bracket to go the other direction. Okay, so then let's comment out this next part and see if there's an issue there. So I'm going to try compiling. Nope, I've got a problem here. And if I read the error message, it says undefined control sequence. So undefined control sequence often happens if the compiler doesn't recognize a command. So you typed / something and it doesn't recognize it. And the most common two reasons for that are: one, the command you're trying to use requires a package that you don't have loaded, or two, there's a typo in your command. You accidentally misspelled it, which is the case here because I meant frac and I spelt farc. So we'll change that to frac and see if that fixes that. And it does. There's my fraction there. I'm going to go ahead and just uncomment all the rest of this stuff, and we'll see how many more errors we have in this file. Okay, scrolling down here, it looks like we still have quite a few. So I'm good up to line 24, even though it's telling me that the next error is on line 26, missing $sign inserted. And I can see right away that it's a $sign issue because remember, when you open math mode using a $sign, everything in math mode turns green. And looking at this, there is way too much green here. Too many things are green that aren't supposed to be green. Only the math should be green. So this text, if that discriminant, that should not be green. So I forgot to close my $sign right here. And as soon as I type that $sign, you can see that that text now turned black, which is how it's supposed to be. So let's try compiling. Now, I still have errors in the document, so it did not update the PDF. This is the PDF from the last successful compile that we did. So be aware of that as well. If you feel like you're clicking compile and nothing's changing over here, it could be because you have a compiling error and it's not updating your PDF for you. And you can turn this message log off, so if you're not, maybe you wouldn't realize that you had an error. Your PDF is just not updating. But for me, the message log automatically pops up when I have errors. Okay, so now let's look at line 27 and see if we can figure out what issue we're having here. So in the align environment, so first of all, I noticed something's weird because it's colored in a strange way. I'm expecting the math to be green and things that aren't math to be black. But this stuff right here, I clicked a $sign to start math mode, but this is black. Why isn't it green if it's in math mode? Well, when you start the align environment here, when you type / begin align, it automatically puts that in math mode. So I'm in math mode before I ever type anything. When I do begin a line like that, I'm in math mode right now. So if I start typing, you'll see it's green because it is in math mode. Now let me go back to what I had. So what happened when I typed the $sign is it actually closed the math mode, and that's causing me errors here. So when you're working in a line, never use the dollar symbols. You're automatically in math mode. Now things look a bit more normal. The math mode is green like I would expect it to be. So let's compile. We still have an error. It's still saying line 27. Now, obviously the problem is not on line 27 because there's nothing wrong with this code right here, this syntax, but it's something to do with my align environment here. If you look at the other code messages that are popping up, so sometimes this will give you a clue as to what's wrong, and other times, you know, maybe it's not, you're not real sure what this means. It looks like missing $sign inserted, but that's not really what the issue is here. Misplaced alignment tab character that's talking about the ampersand. That's not the issue here. The issue here is that we have a blank line in our align environment. And typically blank lines don't matter at all. You can put as many blank lines in your code as you want. It's not an issue. It's not even going to show up as blank lines over here on your document. In fact, the compiler ignores spaces as well. I don't know that I've mentioned that yet. So not in text, not in text mode. In text mode, let's see what happens if I put a bunch of spaces here. Actually, I think it probably will still ignore it. Oh, let me hide this because it won't compile. So there's an error there. So I'm commenting that out so we can see what happens here when I put in all these spaces there. And look here, then there are no real roots. It ignored all of those spaces. You can type as many spaces as you want here and it's going to ignore it, which is kind of nice because sometimes when you have a lot of code, it's helpful to your eye to space things out. For example, up here where we had the square root, especially when you're trying to find an error and fix an error. Sometimes I'll come in here and I will just put a bunch of space. Like I know the /square root goes with that closing bracket right there, and I'll just put a bunch of spaces just to visually separate it so I can focus on the interior, because if I'm sure that this looks correct and it's matching with this right here, then I don't need to focus on that part of the command. I really want to just focus what's in the middle here. So spacing things out in your code can be helpful, and this absolutely will not affect your output. The compiler will ignore spaces. Sometimes it's frustrating because you want a space and it's ignoring the space when you type it, but there is a way to hard code a space. If I want to put a space here, I can just do \, and then I can do that as many times as I want. So let's insert some spaces here. And now when I compile, I should see the square root symbol and then a weird amount of space and then my fraction. So that's happening right here. I've inserted some extra space there. Let's take that away because that's not proper. Okay, and now it looks normal again. So let's go back to trying to fix our issue here. And I think I already told you what the problem was. In an align environment, you cannot have a blank line. You cannot have a blank line. So let's remove the blank line and try compiling. And, oh, I still have another error. Okay, I thought that was going to work. Okay, so I'm not getting any good clues from the message here. So I'm going to look at the code very carefully and make sure I didn't misspell something. Make sure that I have all the matching stuff that I need. Everything looks good. So my next thing to check is there a package missing that maybe I need? So at this point, I'm not sure what the issue is. I always go to Google. Google is your best friend when you are trying to troubleshoot LaTeX errors. So I am just going to Google, you know, some kind of words that are going to indicate what my problem is. So LaTeX, and then begin align. And let's see, I think it's a package issue. So let's see what pops up. So a couple of clues here. I'm seeing use AMS math, use package AMS math, the very first hit. aligning equations with AMS Math. So I think that was the package I needed and not that float package. So let's come back up here and try AMS Math. AMS Math and compile. And sure enough, that fixed the issue. So that was the package I needed. And I think I mentioned this in an earlier video. Whenever I create a document, I always load AMS Math, AMS Sim, and AMS Fonts because I can never remember which one does what, and I frequently need to use these three packages. So just out of habit, I go ahead and load those packages for all of my LaTeX documents. So that fixed the issue that we were having here. Okay, so fixing errors, it can be frustrating, certainly, but you want to try just a systematic approach to it. Use that tip I showed you about commenting out parts of the code so you can really narrow in right where the error is. Use that error log to help provide clues to you so you can see what the error is. And before we go, let's just hop on over to Overleaf and I'll show you what debugging looks like in Overleaf. It's a little bit different. To be honest with you, it's not very pleasant. Okay, and I think I made this sample document. It was a copy of our tutorial with all of these errors in it. So the reason I said it's not very pleasant is just because you see all of this red. Like it just induces panic when I see this. I'm typing on a document and then things all of a sudden turn red, right? It's very jarring. But it's showing me that I do have issues. Now in Overleaf, so I'm trying to compile, it's not compiling. Clearly I'm having a problem because everything turned red. It's giving me some indication of maybe what the problems are, but you see that it's not quite as explicit as it was in TeXmaker where it said line 5 and then line 8 and then line 9. We are getting a little clue right here. This L.5 is referring to line 5 and it looks like /right. It's also identifying what the problem might be there. You really have to read these and look for clues. And then also this red X right here is indicating that we have an error on this line. So we're going to try and fix it. If you remember from last time, the problem was we were missing the /right in front of this other bracketing symbol. Okay, now as soon as I fixed that, notice what happened. The red X in front of line 5 disappeared. But now I've got all these other red X's, so these are indicating other problems. Now this one doesn't make a whole lot of sense. \begin document, like there's nothing wrong with that, but if we hover over this and look at the message, it's saying it's unclosed. In other words, like we have a begin document, but we don't have an end document. Well, clearly we do have an end document. It's down here. But look what it says down here. Hey, I found an unexpected end document after a begin enumerate. So it's seeing this /end and trying to close and enumerate. So now I'm kind of piecing together the actual problem. It's not the begin document. It's not the end document. It has something to do with a begin enumerate that probably wasn't closed. And I have to really like hunt through here, look very carefully at all my begin enumerates and make sure they have matching end enumerates. And if you remember, this one does not. So it's a little harder, I think, to troubleshoot this problem in Overleaf. /end enumerate. And you can see as I'm fixing things, some of that red is going away. It's not panicking quite as much, but now we have other coloring issues going on and oh, things are turning red again. That's not cool. Okay, so now we have a warning here. This symbol is just a warning. It's not necessarily going to cause a compiling error. And if you read the message, it's telling us something about the end of line, which is happening all the way down here. So to me, like debugging in Overleaf is definitely not as easy as it is in TeXmaker. And I would highly suggest if you're working in Overleaf that you use that strategy of commenting out a large chunk of your code so that you can really focus on one little section at a time. But before you even get to this point, the best piece of advice I have for you, I can't believe I haven't said it before now in this video, but the best way to prevent errors or to debug errors is to compile all the time. Compile frequently. Right after you type a line of code, compile. And so you can see, oh, that works, no errors, keep going. Type a next little bit of code, compile. Don't try and type your whole document and then hit compile and end up with 25 errors. Then it's a nightmare to try and fix them all. So compile as you go frequently. Every line, every couple of lines, hit that compile button and make sure that everything is running properly. Okay, I'm not going to go through fixing all the rest of these because we already saw how to do that, how to fix them, but I did want to show you what the interface is like over here. Even though it's tempting to fix them just to get rid of all of this red here. I'm Michelle Crummell, and in this video I'm going to show you some tips for using TeXmaker and some tips for using Overleaf. So we're going to get started by opening up a TeX file that I've already created. TeXmaker is set to be the default program that will open TeX files that are stored on my computer. So if I double click on this file, it's automatically going to launch TeXmaker and open the file within TeXmaker. So here is a file, and this is what our TeXmaker window looks like. Yours might look a little different because I may have changed some options, some of my viewing options. So in terms of what you see on the screen right now, you can change that with these 4 buttons at the bottom. If we open up the structure panel over here, we see first of all our file structure, and right now I just have my TeX file here. I don't have anything else added in here. If I click on some of these other buttons, we're going to see a list of symbols, and if I click on one of these symbols, it's going to insert the code for that symbol. So I want to think about where I'm going to insert this. Let's just insert it at the end of this first list item. So this particular symbol requires math mode. So I'm going to hit $, and then let's say I forgot the symbol for plus or minus. I can come over here, click on plus or minus, and it's going to insert the code for that symbol for me right here. And now when I compile, I should see the plus or minus appear. So to compile my document, I have a few options. What I usually use is just F1. F1 is keyboard shortcut that is going to run the code for me. So I hit F1 on my keyboard, and my document compiles, and I can see the result over here. And sure enough, I've got that plus or minus symbol right over here. Another way that I can compile my code is using the quick build option up here. And in this drop down menu, you can decide what's going to happen when you press on this arrow. So I like to have it set to quick build, and quick build is going to do 2 things. It's going to run the code, it's going to turn it into the PDF, and then it's going to show me the PDF. So we can change what quick build is doing in our preferences. If we go to TeXmaker, preferences, quick build, right now when I run quick build, or when I press quick build, it's going to run PDF LaTeX plus view PDF. So you can see that there are quite a few other options that you could select instead, but this is probably the one that you're going to want to use. So I would hit this arrow right here, and that, like I said, is going to run the code and then show me the PDF. Now if let's say I take away the plus or minus. Okay, so now when I run my code, it should remove that plus or minus symbol, and I should not see it on my PDF. If I come over here, view PDF, and I click that, nothing changed. I still have the plus or minus there, even though it's not over here in the code. And that's because view PDF does not recompile your document. It only shows you the PDF from the last successful compile. I have not recompiled. So just clicking on this arrow right here is not going to do anything but show you the PDF from the last time you compiled. It's not going to recompile. So you have to make sure you're clicking on this arrow, not this one over here. Click on this one, or like I said, use your keyboard shortcut of F1, and that recompiles, and we can see the plus or minus symbol has disappeared. So you have other categories of symbols over here. We've got arrows, different symbols, brackets, Greek letters, most used symbols. This is going to populate automatically based on what you've clicked on in the past. And then we've got our favorites. The star here is a place where you can store your favorite symbols. So if there is something that you think you'll use frequently, maybe, I don't know, I'll just use this summation symbol. You can right click, add to favorites, And then you can quickly find it by clicking on that star icon and then just choosing it over here. If I click on this, it's going to insert that into the code, but I don't actually want that there. Okay, I'm going to go ahead and close the structure panel, so I'm not using it, so I don't want it to take up space on my screen. We have some other things that we can click on over here to call up some other commands. So if you need to start a new section, you can do that this way, and you can type the name of the section that you want. I'm not sure where I left my cursor, so this is probably going to put it in a bad place. In fact, let me cancel. Let's say I want to create a section right here. So I can go to section, and I don't know what I want to call it, section 1. And I'll hit OK, and it's going to insert the code there to start this section for me. And then if I compile, we can see that it added section 1 for me there. You have other options that you can use. Just click on here to see what you've got, all of your different font sizes. This one can be helpful. It's hard to remember sometimes what the smaller font sizes commands are. If you want to use this one right here to make something bold, you want to highlight the text first. So let's say I want to have chain rule in bold. I would highlight chain rule and then I would click on the B, and you can see that it inserted /text BF, the curly brackets, and my text is inside. So now when I run my code, chain rule is in bold. Okay, so that can be a bit of a time saver. And same thing here with italics. Emphasis is another way to do italics. Here we've got some justification symbols. This one, and if you hover your mouse over here, it'll pop up a little box that tells you what it's going to do. So this is going to insert a new line. Here we're going to get $signs, a pair of $signs, etc. So you can look at these different options. A fraction is something that people frequently use, so that's handy to have it right here in this toolbar. Same with the square root. But remember in TeXmaker, when you start typing a command, so let's say we want a square root, we've opened math mode with a $sign. If I start typing \SQ, it's going to pop up some suggestions for me. So the top one would be for an nth root, and the bottom one would just be for a square root. So that would give me the square root of x. So you can decide if it's faster to just type it by hand or maybe to click on some of the buttons over here. Before we look at some of the other things in our menus, let's go ahead and open the TeXmaker preferences and see what we have going on there. Under this Commands tab, I just want to point out that you do have the option with your PDF viewer to use the built-in viewer or an external viewer. When you use the built-in viewer, that's what allows the PDF to show up in this pane over here on the right, which again you can toggle on and off at will. If I switch to an external viewer, let me go back into my preferences. If I switch to an external viewer, and it's one or the other, you can't have both selected. The external viewer is going to, when I ask to view the PDF, it's going to open it up in a different application outside of TeXmaker. So by default, my computer uses Adobe Reader to open PDFs, so I'm pretty sure that's where it's going to open. So now you'll notice I don't have the option to view the PDF in a pane over here. That went away. So now when I want to view my PDF, so I can quick build, remember, will also run view PDF, or if I just want to view the last successful PDF, I can click here, and that popped open in Adobe Reader. So there's my PDF. I prefer to have the built-in PDF viewer because I'm constantly looking at my PDF. I'm constantly compiling as I work to make sure that I catch any errors right when they happen. So let me go back into my preferences and go back to that built-in viewer. If you use something other than Adobe Acrobat, you can always change the path here. So click on this folder and then just go into your applications folder and find that executable file that will launch whatever PDF reader you have installed. Okay, so let's move on to quick build. Actually, nothing new to talk about here. I showed you how you can change the setting, but I'm confident that this is the one that most of you are going to want to use. Under the editor, if you change the font family, or the font size here, it's not going to affect your PDF output. It's only going to affect this little text editor part of your screen. Okay, so it's not going to affect what's put on your PDF output document. Now, for the purposes of this video tutorial, I made my font size pretty large. 24 point is pretty large because I wanted you to be able to see the text clearly. When I'm working, I normally work with it at size 16. So that's more comfortable for my eye and I can see more of the code on my screen. This is normally the font size I work in. But again, you can change this. You can make it smaller, you can make it larger. So when I'm recording videos, I like to set it to 24. There are some options over here for you to consider. Word wrapping, I like to have word wrapping turned on. So in my text editor, let's slide this over. Here, we'll just slide that over some more. When I get, when I run out of room here, it's just going to wrap down to the next line. So I like that because I always want to see all of my code on the screen, but it does make this file take up a lot more space on the screen. So if that's not something you want, you can turn off the word wrap. Completion. So this is that auto completion, like when I started typing the code for a square root and it popped up a suggestion on how it thought I might want to complete that command, then you just hit enter when you like the suggestion. So that is, I find that to be a time saver. I like having the completion turned on. Show line numbers is also really useful, especially when you are trying to debug your code, because an error message will come up and tell you, hey, there's an error on line 14, and then it's very easy to find that in your code. You can just go right to line 14 and see the code. You'll notice that some lines don't have numbers next to them, and that's because of the word wrapping. So this technically, this part right here, it's not going to let me click on it because I have this other window open. This where it says to solve, this is not a separate line. It's part of the previous line, so it doesn't get numbered as a new line. Versus this empty line here, I had to hit return to get to this empty line and then return again to get to this line. So even though there's nothing there, this does count as a line number. Okay, back over to our preferences here. Back up your document every 10 minutes. You can certainly turn that on if that's important to you. The reason I don't have that turned on is because when you do have this turned on, then for all of the files you're working in, the compiler is going to, or the program is going to create this extra file. It's going to be also called tutorial 8 and it'll have the extension BAK. So in your folder, let's see if I still have that. In the folder here, there would be another file that says tutorial_08.bak. And my folders, I just feel like have a lot of files in them as is, and I don't like having that extra file in there. But it's no big deal. If you want the safety of backing up your document every 10 minutes, you can do that. I almost always recompile more frequently than 10 minutes, so it's not really useful for me because every time you compile, it's going to save that file on your computer. So that acts as backing up every so often as well. Now, this is a good time to point out when I first launched this file, this tutorial8.aux.log and this .syntax.gz were not here. The only thing that was in here was this CMG project and then the tech file and the PDF. But while you are compiling your file, these other auxiliary files are being created. These helper files are being created. And they will stay in there and they will clutter up your folders, and you really don't need them. Once I close TechMaker, I'm going to show you. I'm just going to come in here and close TechMaker. Oh, it's not going to let me because I have this window open. Okay. So now let me try. Close TechMaker, and look, those helper files disappeared. That doesn't happen automatically. That only happens because I set that up in my preferences to happen that way, but it helps just clean up the folder so I don't have a lot of extra unneeded files cluttering up my folders. So let me launch this again. I'm just going to double click on this to open that up. And if we look at that, we see we just have these two files, but now if I compile, Or I could have stayed on this. No, I couldn't have. There we go. Okay, so now we've got all of those helper files in there. So how do we change that setting to get rid of those helper files when we don't need them? In your preferences, right here, you're going to make sure this box is checked. Launch the clean tool when exiting TeXmaker. So when you X out of the program, it's going to remove those extra files that are not needed. Okay, so we were looking at the editor window. Tab width, number of spaces, you can increase or decrease that as you like. So that would be when I'm working in my code and I want to indent by hitting tab. That's just how many spaces it will indent. So you can customize that. You can change the color of certain things. So you'll have to know the hex code for the color that you want. This is white. So the background that I'm working in, again, it's not going to affect your PDF output. It's just this editor panel here where you're typing your code. If you want the white background, there's a dark theme and there's a light theme. So if you like working with like white text on a black background, you can go with the dark theme. Or I don't know if it's white text actually. I don't typically use the dark theme. But right now the background color is set to white. The highlighted line, I forget what color that is. That might be correct. I don't remember. This is black. This is gray. This is green. So when you're in math mode, it's going to show up as green. So you can customize that if you don't like the default colors. You can come in here and change the hex code. Okay, and then the shortcuts tab here is just going to give you a list of keyboard shortcuts. And if there's something that you find you're doing frequently and there's not already a keyboard shortcut for it, you can add a keyboard shortcut for it. So the things that say none, you can click on that and then you can define your own custom keyboard shortcut. All right, so that takes care of preferences. And we've looked at this toolbar. We sort of talked about the important stuff on this toolbar. What have we got up here? So TeXmaker, this is where we found preferences. If you're on the Windows version, you may have to go to options to find preferences. At least that's the way it used to be. But on the Mac, it's TeXmaker and then preferences. File, we've got standard stuff here. Edit, these 4 commands are very helpful and I use the keyboard shortcuts for these all the time. So if you want to comment out a line, let's say, for example, I don't want these last 4 items in my list to show up on my PDF. I can use the keyboard shortcut, which is Command T, and it's going to put a % at the beginning of each line. And so by line, I mean the numbered line where they're numbered. And then when I click off of that, you'll see that it also changed the color to gray. So that's another indication to me that something is commented out. And what we mean by commented out is that the compiler will ignore that line of code. It will not even consider it when it is running your code. It's just going to ignore it when it gets to that line that's been commented out. So one use of commenting things out is, maybe you don't want something in your document. Let's compile. So there I just got rid of some of those questions. But you don't want to delete it because maybe you're uncertain and you want to show it later on. So I do that sometimes when I'm writing a quiz or a test. I have a question that I decide to omit, but I don't want to delete it because I think, well, maybe in the future, or if I'm making a makeup test, I might want to then turn on that question. So that's a good way. If you're troubleshooting and you're trying to figure out where an error is, commenting out a bunch of lines can really help you pinpoint exactly where the problem is and help you fix it. Now, to undo that to a bunch of lines at once, we can use the keyboard shortcut Command U, and that will make them all visible again. Another use for comments is just to leave little reminders for yourself, especially when you're first learning LaTeX. Maybe you don't, remember what a certain piece of code means. This, for example, on line 3, will remove paragraph indenting. So I could leave a comment here for myself. I just go to the end of the line, not the beginning, because then it won't run the code. At the end of the line, type your % symbol and make a note. So this will remove the indent. And it doesn't necessarily have to remove the indent, but the 0 is going to cause it to have an indent of 0 space. So I could put a number there instead if I wanted 10 EX. EX is a unit of measure. Then that would give me large indents, but I typically turn off indenting in my documents. So another good use for comments there. Indent, indent and unindent would be not for the PDF output, not to confuse you because I was just talking about indenting here. This is the code that will affect the indenting in your output document. But sometimes you want to indent your code. So maybe we want to indent these lines right here. I can do that all at once if I hit, and I'm on a Mac, so it's Command Shift and then the right angle bracket, and that will indent. If I hit it again, it will indent more. So it's a good way to organize your code, make sure things are lined up that all belong together. And you can undo that or reverse that by Command Shift and then the left angular bracket. And again, if you forget the keyboard shortcut, you can always just access it from the menu here, or you can look and see what the keyboard shortcut is from the menu here. Under the LaTeX menu here, you've got all kinds of different options. If you forget the code for something, you've got it right here. You can just click on it and it'll insert the code for you. I don't know where my cursor is at the moment. Let's put my cursor in a good place. Well, we'll just put it at the end of that sentence there. Okay, so one that I find hard to remember, I have a lot of this stuff memorized, but one that I find hard to remember sometimes are the international accents. And this comes up when I'm trying to type L'Hôpital's rule. So for L'Hôpital's rule, we need a special accent over the O, and this is the command right here. I'll just put an O there. So it's capital L apostrophe H O, but it's the accented O, L'Hôpital. And then let's build that, and we can see it right there. It's got the special accent over the O. So the pull-down menus are great for things that you don't use too often. You don't remember what the code for them are. It is our math. We have other menus here. If you just kind of hover over, you'll see what's available there. The wizard is cool. I'm going to just close this document. I'm not going to close TechMaker. I just want to close this document. And let's start a new document. So this old PDF is just hanging out over here just because I haven't recompiled something yet. So let's start a new document. So I'll just click the new, and we can start from scratch, or we can use this wizard to get started. Quick start. It's going to ask me for some basic settings. We want to use the document class article. If you're doing a slide presentation, you would use Beamer, but we have article, and you've got some options here. You don't have to use any of these options. You can ignore that if you don't need it. I don't see anything here that I want. You can decide if you want to go 10, 11, or 12 point. Let's go 12 point just so this is a little bigger for the video. Paper size, you can choose the size paper that you would be printing on. So in the US, we use letter paper. The author, if you want to include that, if you know that you want to include your name in your document, you can do that. If you know the title of your document, I mean, you probably do. This one that we're working on is critical thinking question, or we'll just say IB Math Analysis and Approaches. HL. Okay, geometry package. Do you want to load the geometry package? That's pretty useful. And then you can specify all of your margin sizes, although I don't like the ones that are being offered here. I would prefer 1 inch margins. And if I want them all to be 1 inch, I can just say margin equals 1 inch. AMS packages, absolutely, I always include those. The graphic X package, if you're going to have images in your file, so that one is useful, and that's all I need. I'm going to hit OK, and I've got some basic stuff here to get me started. I usually like to space out things a little bit here. After my packages, I'll leave an empty line. Okay, that looks good. And if this, I don't know what's going to happen with the dot here. Let's see if we get an error. Yeah, we do. Oh, but for a different reason. It won't compile your document if you haven't saved it and named it. So you got that could not start the command error. It looks like, hey, I have code here. Why aren't you compiling? And it looks like it has a name, but it actually doesn't. I have not saved this file yet and named it. So we have to do that. So do file, save as, and then let's put it in the same folder, tutorial _08b. And we'll save that. Okay, so now my file is named. Never, 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 never use spaces in your file name. You'll notice I put the underscore there instead of typing a space. Do not put spaces in your tech file names or your image file names. It can cause issues. Okay, now let's see if this dot is going to still result in an error. It does not. Okay, so sometimes people message me and they did something like this, and then they try and compile and they get an error. Oh, now it's not going to work because it still remembers this. But if that happens to you, the reason that you're getting a compiling error here is because you haven't actually typed anything between your begin document and your end document. It looks like, you have typed a lot of stuff up here, but this is what we call the preamble. The part of the code that comes before begin document is just your preamble. It's like presetting certain things up. And you can't run the code unless you actually have something in between your begin and end document. So even if it's something simple like hello, and then we can run that and no issues there. Okay, so quick start, there we go. Quick start can be a helpful way to get you started from a blank document. And you've got an option to do a quick start for a Beamer presentation and some other options as well. If you want to insert a table, you can also use the wizard there. Quick tabular is going to bring up this window, and you can enter how many rows and columns you want in your table, and you've got other options here if you want to align the contents of your cells left, right, or centered, or if you want them to be in like paragraph form. If you're not entering numeric values, if you're entering text, you might want to switch to paragraph, and where you define the width of your columns there. You can also merge some columns. You can decide if you want a border on the left and the right and at the top and at the bottom. So you can have all of those or none of those or some, but not all. And you can check what you want there. You can add a vertical margin for each row if you want that. And when you click on OK, you can even come up here and type, I think, can you type contents? Yeah, absolutely. You can even type the contents of your table. Now that should be in math mode. So tables can be a little bit tricky to code by hand. Why is that not cooperating? So this is really nice to have sort of a visual way to create your table, and then you hit OK and it's going to insert the code for you. At least it's a good way to get started. You can add more columns. You can obviously edit this table now in any way that you like. So let's take a look at that. There we are. It's pretty simple. What else are we going to look at? Under user, I want to show you this. This is super helpful. I use this all the time. You can store bits of code and then just call them up instantly. So this is really great. When I am, let's see, which one do I want to look at? Well, if you want to add your own, you're going to go to Edit User Tags and then click on one. You can only store up to 10, so click on, this one is empty. We could do a new one here, or we can just look at something I already have. So this is something that I use often, and I'm certainly not going to have this code memorized. But this is going to insert a little calculator symbol. So I often do this next to like calculator active problems if I'm assigning homework. So I have this stored under menu 8, and I can type the code. Let's say I want the little graphing calculator symbol right here. So the command is /calculator. And then I need to put the code for that in the preamble. So I'm going to come up here. Now I can come up to user tags, and then just either click here for calculator icon, or if I know the keyboard shortcut, it's just Shift F8. So I can just do Shift F8, and that inserted all of these lines of code here for me, so I don't have to have them memorized. Now, I have lots of little code snippets that I use over and over again, and I only have 10 slots to store them here in TeXmaker. So what I actually do is open Google Keep, and I store all of my code snippets on separate little Google Keep notes, and so I can always find them easily there as well. That's another tip for you. Okay, so that is looking good, and now when I run this, I've got my little calculator symbol in front of hello. Okay, view, you can turn on and off different toolbars, options, help. So notice under help, you do have access to a LaTeX reference and a user manual. The user manual is going to help you with TeXmaker specific stuff. That opened that up in a separate window here. But you can learn all about TeXmaker and the different options, and if you're having trouble with some aspect of TeXmaker, that can be helpful. You also have the LaTeX reference, which you can look up different types of commands. So if you want to learn more about equation arrays, you can click here and then read more about equation arrays and get some sample code and some explanation on how that works, or any packages you might need. Like this one, it tells you have to use the AMS math package if you're going to use an equation array. So that can be a great resource for you as well. Okay, let's switch over to Overleaf, and I'll show you how to do a few things here. So I am logged in. If I want to start a new project, I'm going to click on New Project, Blank Project. Notice that there are lots of templates available though, and Overleaf has a template library with tons and tons and tons of templates that you can use, which is really great. If you're typing up a science lab report, they have some templates that you can start with, resumes, all kinds of things. But we're just going to go with Blank Project. And we will again call this tutorial 8 Overleaf. And that's just the title of the project. But notice that when we create this, that's not the title of the file. I told you never, never, never put spaces in your file name. And I did put spaces in the title, but that is not the name of the file. The name of the file is what we see right over here, main.tech. And I always recommend to my students when they're using Overleaf to change the name of that file, because every time you start a blank project in Overleaf, it's going to call the file main.tech. And so it just gets confusing when you have lots of files that are different, but they're all called main.tech. So I always recommend renaming that. We'll call this tutorial 8C. There we go. And you can, in this pane is like the structure pane that we had in TeXmaker. So if you do add more files to this project, they will appear in the list here. If you want to go back to the main menu, you would think that you should click on menu, but that is actually not going to take you back to the main menu. If you want to go back to the main menu, you click on this arrow right here, and that's going to take you back to this main screen here. So now to go back to my project, I can just click here. And we've got some basic code here to get us started. If you don't like what's here, you certainly can type over it or delete it and start with something else. You can, if you're loading a template, you'll have lots of code in here for you, and you can just edit it as you need to. So I'm not going to do much with the code. I just want to point out where certain things are in Overleaf and also show you how you can download copies of your TeX file and your PDF document in case you need to send it to someone or submit it to your teacher. This panel right here, just like in TeXmaker, is where we're typing our code, and you have the option to switch to the rich text editor. I don't recommend this, but I guess it can be helpful if you're really, kind of unsure of what something is going to look like, and maybe it's not compiling because there's an error. This might give you an idea of what your work is going to look like. But I recommend sticking to source and just working with the actual code here. When you're ready to run your code, you're going to click on recompile, and then it will refresh and show you your PDF output over here on this panel. If you are working on a small screen and you know this is very tiny and you can't see it very well, you can also collapse some of these panes. So you can click on right here to go full screen, and now it's just the PDF. So you get a nice big zoomed in view of your work, and then you can go back to split screen. You can also drag this separator to the left, which will increase the size here and has the same effect as zooming in, or you can drag it to the right. This side will get smaller, this side will get larger. So you have some options there. You can also close these panels using these little arrow symbols right here. So now I've hidden that PDF panel, and then I can bring it back like so. If you want to share your document and have multiple people working in this same document, you can do that. So here's what I recommend for my students. When you want to share a document, don't use this option here where it says share with your collaborators. I mean, intuitively, it seems like that's what you should do, right? You type in someone's email address and then you share it with them. Well, in the free version of Overleaf, you are limited to how many people you can collaborate with. And so another option, instead of doing that, would be to turn on link sharing up here. Turn on link sharing, and then anyone with the link can edit your project if you share this link with them, or anyone with the link can view your project if you share this URL with them. Okay, so if you are working in a group of 4, for example, this is the way you want to go. Turn on your link sharing. Anyone with the link can edit the project, send your collaborators this link, and they will all be able to work in the document with you. You can also turn on chat, and so if multiple people are working in the document, you can have a chat message going on about certain things. You also have the option of commenting. Commenting in TeXmaker is gray. When you comment here in Overleaf, it's this bright blue. So it's really easy to see the I like that. Maybe I'll change that in my TeXmaker and make it blue instead. So it's easy to see comments. That's another way you can communicate with people, is by leaving comments in parts of the code, but the chat is another option for you. Okay, let's say you're done with your project and you want to download a copy of your PDF. So that is very easy to do. You just click on this icon right here and it downloads the PDF for you. And then you can open that on your device and it'll open in whatever PDF viewer you normally use. So there's my PDF. And it downloaded it by default into my downloads folder, so I can find it there on my computer. If you want to download your TeX file, that is not quite as easy. In fact, it's much more difficult to do that, especially for my students who are working on a Chromebook. But if you want to download your TeX file, you're going to come over here and click on Menu, the thing that you think would take you back to the main menu, but it doesn't. So click on Menu, and then you've got 2 options here. If you click on PDF, it's going to download the PDF, but frankly, the other way to do it was easier. Or you can click here that says Source. So that's what you're going to want to do. You want to click on Source, and it's going to download, not your TeX file, it's going to download a zip folder. And in that zip folder, you will find any of the files listed here. So if you've uploaded images, or you have multiple TeX files here, or whatever files here, any files you have here that are associated with this project, when you click on Source, it's going to download all of them in a single folder and zip that folder and send you the zipped folder. So that folder is called Tutorial 8 Overleaf, that's the title of my project, .zip. Now on a Mac, this is really easy to deal with. So I just find it. I just clicked on that and said show in Finder, but you can also just go to your downloads folder and it's right here, Tutorial 8 Overleaf.zip. All I have to do on my Mac is double click on that and it unzips it. And actually, when there's more than one folder, it looks a little different. So let's go back here and add something. Let's add an image in here. I'm going to upload, and I'm just going to drag an image from my desktop. Okay, so I've added an image here, and I warned you not to have spaces in your file name, so I'm going to rename this. Okay, so now I have an image and a text file, and I want to download at least my text file, but really it makes sense to download both because no one can run your text file if they don't have a copy of the image. You'll get a compiling error. Okay, so let's try this again. All I have to do is click on this, and it's going to, this was the zipped file. I already had one with the same name, so that's why I put the one at the end. This is the zipped file, and when I double clicked on it, it unzipped it, or sometimes we call that extracting, but now I just have a regular folder. This is not zipped anymore. So when I look inside that folder, I see all of my individual files. I've got my text file and I have my image file. What I don't have here is my PDF. This doesn't make sense to me. Why don't they just don't also include the PDF as part of this? That would be nice, but if you need both, you're going to have to download them separately. Okay, so now you have access. This is in my downloads folder. I can move it anywhere else I want to on my computer. I can upload it into Google Drive. I can upload it into my learning management system like Canvas, or really I can do anything I want with it. And to get back to our text file, just click on it, and then that will make that the active file again. So I think that covers everything I wanted to show you in Overleaf. And I hope you're able to use some of these tips to help you work more efficiently.
Hello, and welcome to another video in my LaTeX tutorial series. Today we're going to be talking about some common notation that you would see in calculus, such as limits, integrals, summations, and vector notation. I'm starting with a very basic setup. All LaTeX documents start with the command \document class, and I've set this one up to be 11 point, and the type of document is an article. The only package I'll be using for this tutorial is the geometry package, and that is simply to adjust the size of my margins, so that is optional. You don't have to use that. The body of our document will type in between the commands /begin document and /end document. I'm going to begin by identifying the domain and range of a function. The function, and now I want to enter math mode, so I type my $, f of x equals, and in parentheses I want x minus 3 squared, so I raise that to the power 2, plus 1/2, \frac, and TeXmaker is going to fill in the rest of the command when I hit enter. And I can tab to get to the next part and move my cursor outside of the braces. And let's go ahead and compile this and make sure it looks the way we expect. Remember, when you open a new document, you must save it and give it a name before you try and compile it, or you will get a compiling error. Now, I usually hit F1 as a keyboard shortcut to compile my document, but for the sake of the tutorial, I'll probably move my cursor up here and build it by pressing the arrow. That looks good. We have the function f of x equals the quantity x minus 3 squared plus 1/2. So I'm going to continue typing. Has domain. And now to describe the domain, I want to name it with capital D, and I'm going to go into math mode. I want a subscript of f, because it's the domain of function f, a colon, and the domain for this function is all real numbers. Now we do have the option of using the symbol for all real numbers, but I'm going to use interval notation. So our domain goes from, and we're using, it's an open interval, so parentheses, -infinity. Negative, we're just typing the minus key on the calculator. For the infinity, it's \infty. That's -infinity, comma, and now I want positive infinity, or just infinity, so \infty. Close my parentheses, and let's end math mode and compile that, see what it looks like. Okay, now the one thing I would like to change is the D. I don't want it to be italicized. Because it's in math mode, letters are always going to be italicized. But I can make that not in italics if I come back to my code and I type, basically wrap it with the tag mathrm. So move your cursor in front of the D, \mathrm, and then the curly brackets around the D. Now when we compile it, our D should not be italicized, but the F still is because it's outside of those curly brackets. So let's finish by describing the range. So the function f of x has domain from -infinity to infinity, and range. So I'm going to do something very similar here. I'm going to use a capital R for the range. So I'm going to go into math mode, but I don't want the R to be in italics. So \mathrm, and in TeXmaker you can see it's trying to complete the command for me. So if I hit enter, it'll type the braces for me, and I can just type my R in the center there, and use the right arrow to come out of the braces. We want the subscript of F, colon, and now our range goes from 1/2 to infinity, and I do want to include the 1/2, so I'm going to use a square bracket around the 1/2. To get the 1/2, I'm using the command for a fraction. Comma, infinity. So \infty. Open parentheses. Close math mode. Now let's typeset that, and I have a feeling I'm not going to be happy with the way it looks. Let's try. Okay, so what I'm not happy about is the square bracket here is not large enough to surround the fraction 1/2. So I explained this in an earlier video on delimiters, but if we want to automatically expand the size of the brackets or braces or parentheses, then we can change the command slightly. So I need to find where that bracket is. So right here I'm going to put my cursor in front of it, and I'm going to type /left, and that is going to automatically fit that bracket to the size of what comes after it. And then the parentheses on the right, I also want to insert my cursor just before it and type /right. So if you use the /left, then you have to balance it somewhere with a /right. The compiler will be looking for that. Okay, so now we can see that both of those delimiters have expanded. The other thing I might want to do, notice that the 1/2 is smaller than the 3. This has shrunk it to fit neatly on a line because it's in line. If we wanted that to display at full size, we could go back and use the display style command. This doesn't bother me. I think it looks good the way it is, so we'll see how to use the display style in another example here in a moment. Let's move on and look at how we can type a limit. And I'm going to go ahead and end this with 2 backslashes to give myself some more space. And to type a limit, the basic command in math mode is \lim. If I just end math mode here and compile, you can see all we get is lim, and even though we're in math mode, these letters are not in italics because the compiler understands that this is a special string of letters. Now we want to adjust this. We want to take the limit of something, and we want to take the limit, let's say we want to take the limit as x approaches a. I'm going to use another command, \limits, and that is going to be followed by, I'm trying to get as x approaches a, so underscore, and then in curly brackets I want to type x and then an arrow and then a. So the symbol to get that right arrow is \2, T-O, A. And I'm going to close my curly brackets, and now we should see when we compile it the limit as x approaches a. Okay. If I did not use this limits. Take that out and recompile. As x approaches a will not be underneath the lim, it will still be a subscript because we used that underline, but it's going to appear to the right, which you may want. I don't like it like that, so I'm going to go ahead and put the \limits command in front, and now the x approaches a will be underneath the word limit. If I want to take the limit, and we have to take the limit of something, so let's come back and add our function. In general, let's just call it f of x. So we want the limit as x approaches a of f of x. If I want to take the left-hand limit, the limit as x approaches a from the left, I just come back to my code, and after the a, use the caret. You can type a plus if you want to approach from the right-hand side. If I want to approach from the left-hand side, I'll type a minus. Okay, let's do one more example with limits. We want the limit, so \lim, and to make the notation look a bit nicer, I'm going to use \limits underscore, and I want again just the limit as x approaches a. So in my curly brackets, x \2 to, the limit as x approaches a. Close my curly brackets, and this time I'm going to use the definition of derivative at a point. So the limit as x approaches a of, now I want the fraction f of x minus f of a over x minus a. So \frac in my numerator, that's the first set of curly braces or curly brackets. We're going to type f of x minus f of a. In the denominator, so this goes in the second pair of the curly brackets, x minus a. And that, let's come outside of the brackets there, is equal to f prime of a. So f, and I'm just hitting the apostrophe for that prime symbol, of a. Close my math mode. Let's compile this and see how it looks. Alright, I forgot to end my line with 2 backslashes. That'll give me a little bit more space in between there. Now this looks good, but the fraction is displaying rather small, and that's because it's trying to fit it nicely in with the line. But I want to make it look normal size. So I'm going to come back to my command and wrap the entire thing with display style. \display style, curly bracket, and then at the very end, before I exit math mode, put the closing curly bracket. And let's compile this again. Okay, so now the fraction looks much larger. Same size as the rest of the notation. And that line with 2 backslashes. And now let's look at how to typeset an integral. In math mode, we're going to start with \int for integral. Let's take the integral of sine of x. Now if I just type sin, when I compile that, it's going to be italicized. I don't want that. So for sine, cosine, tangent, all the trig functions, we do backslash first. So \sin of x, and that should give me the integral of sine x. Now I also need my dx. I can type dx just like this, close math mode. Let's see what that looks like. Now notice that the x and the dx are kind of look like they're running together there. So what I like to do here is just force a space to be inserted between those. Because remember, just because you type a space over here in the code doesn't mean it's going to appear as a space when you compile your document. But to force a space right there, I'm going to hit \, comma. So let's compile that and see if it makes a difference. Okay, good. So now there is a space between my x and my dx. Now if you don't want the d italicized, we saw, as we did when we were typing domain and range, how we can wrap that lowercase d with the \mathrm tag, and it wouldn't be italicized. But the italics don't bother me with the dx, so I'm going to leave it like that. Let's go ahead and solve this integral. So the integral of sine x dx equals negative cosine x, so I'm going to do backslash cosine x. Now let's talk about spacing for a moment. Over here I left a space in between or in front of this slash sign. That's optional. I didn't over here, but I did leave a space between the s and the x here. Otherwise the compiler might get confused and think your command is backslash cos x all as one thing. So we want to separate that with a space. And let's not forget our plus c, very important. And we'll compile that. And there we go. If I want my integral sign to be longer, so when you see it in a textbook, you see it online, usually it doesn't look that short. And it's shrunk here to kind of make it fit in that line neatly. But we can expand that simply by using display style. So backslash display style, curly bracket, and then just before we end math mode, put the closing curly bracket. And that elongated that integral symbol. Next, let's look at a definite integral. So we also start with backslash int, that's the command for integral. But this time we need to show that we want to take the integral from a to b. Now I can simply use an underscore and type a caret b. Let me close math mode and see what that looks like. Okay, so that gives me the short integral, but it is going from a to b, and my lower limit and upper limit of integration appear to the right of the integral symbol. We can also use backslash int with the backslash limits command, underscore a caret b. And now we have an integral where the a and the b are not to the right of the integral symbol, but they're above and below the symbol. So you can decide which one of those you prefer. If you want the integral symbol elongated, simply wrap it with display style. I'm going to just copy those last two commands, and we'll see what they look with display style in front. Okay, so we get longer integrals, which sometimes looks nicer. Let's continue working with our definite integral to talk about some problems you may encounter along the way. If one of your limits is more than one character, then just using the caret is not going to be sufficient. So for example, let's say for some reason you wanted to go from 2a to b. Let's see what happens when we compile this. Okay, that's probably not what you were expecting to see. So what we're going to do to fix this is after the underscore, the lower limit, you want to wrap that in braces or curly brackets. And then we can do the same for the upper limit. Now if it's just a single character, it's not going to be a problem. But if you have more than one character, you will need to do that. So just to be on the safe side, you can always use the curly brackets, then you shouldn't run into any trouble there. So now we have our integral with the lower limit of 2a and the upper limit of b. Let's go back to just a and b. I'm going to keep the braces. Okay, now I'm moving my cursor in front of the last curly bracket because that goes with the display style command. So let's take the integral of something. Let's take the integral of x squared dx, and remember I want to insert a space. Just typing a space is not going to insert a space when I compile this, so I'm going to use backslash comma dx, and we'll compile that and make sure it looks good. So we have the integral of x squared dx from a to b. and that is equal to. Now there are a couple different notations you might see for evaluating a definite integral. I usually use the square brackets around the expression. So I'm going to type the square bracket for the left side. When we integrate this, the antiderivative for x squared is x cubed over 3. So I could write 1/3 x cubed. I'm just going to go ahead and write x cubed over 3. So I want the fraction x cubed over 3. Because this is a definite integral, we need to input our lower limit and upper limit. So let me end with a square bracket, and then to get my limits on there, I'm going to use the underscore and then lower limit of a caret upper limit of b. So again, if it's a single character, you don't have to wrap it with the curly brackets, but to be on the safe side, we can go ahead and do that, and just so you're familiar with the notation. Okay, now let's see what that looks like. Because I have a fraction, I have a feeling I'm not going to be happy with the brackets. Okay, so the lower limit and upper limit do appear in the correct place in relation to the bracket, but the bracket needs to be expanded to the height of the fraction. So I'm going to go back where I typed my opening square bracket, and in front of that, backslash left. Where I typed my closing square bracket, in front of that, I type backslash right. And we'll compile that, and that looks much better. And let's go ahead and finish evaluating our integral here. So that is equal to backslash fraction b cubed in the numerator over 3 in the denominator. And I need to move my cursor to the right so that I'm outside of that first fraction. And now it's minus, and we plug in our lower limit of a, so I need another fraction, backslash frac. Our numerator is a to the power 3, denominator 3. Let's compile that. The next thing we're going to look at is summation notation. To get the capital sigma, we're going to use the command backslash sum. If I compile that, it's going to be pretty short. So usually that is written much larger than the text beside it. So we can make it larger using display style backslash display style curly bracket, and we go to the end and put the closing curly bracket. If I compile that, now you can see the size is much larger. We want our sum to go from n equals 1 to infinity. I'm going to use backslash limits. So I'm going to use then an underscore, and on the bottom I want n equals 1. That's not a single character, so this time I have to use the curly brackets. N equals 1, close the curly brackets, use the caret, and now we're going to type our upper bound. So this time I want to go to infinity. So in the curly brackets, I'm going to type backslash infty and close the brackets. Let's compile and see what we have there. Okay, so we have the sum from n equals 1 to infinity. And let's keep going with that. I need to be in front of the last curly bracket because that closes the display style. And we want to take, let's see, the sum of, let's do geometric series, a times r to the power n. And that is equal to, let's go ahead and compile so we can see where we are. I'm going to go ahead and expand that sum. So that is equal to a plus a times r plus a times r squared plus, now I want dot dot dot, plus my nth term a times r to the power n. Let's compile and see what we have. I have the dot dot dot, but the dot 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 should be centered vertically so that it's kind of aligned with the horizontal crossbar of the plus sign. And instead of typing dot dot dot, there's a command for the 3 dots. I don't need to insert space between it, but just to keep the code nice and clean, I will. And that command is slash. If you just want a single dot, it's C dot. If you want the 3 dots, put an S at the end, backslash C dots. So when I compile this, those 3 dots should be vertically centered. For our next command, we're going to put all of this stuff together and give the definition of a Riemann sum using a definite integral. So let's open math mode, and the first thing I want to type is the definite integral of f of x from a to b. So we're going to do display style, open curly brackets. I'm going to go ahead and end them and end the math mode, and then just type in between those brackets. So we're starting with an integral, so backslash int underscore and then a caret b. My function will just be f of x, and then to insert a space here, backslash comma dx equals. Let's compile, just make sure we don't have any errors to this point, and everything looks the way we expect. Okay, with the integral from a to b, f of x dx is equal to. Now we want the limit as n approaches infinity, so backslash lim. I want to use backslash limits so that the x approaches infinity part appears underneath the lim. So underscore, curly brackets, x, and then to get the arrow, backslash 2, to, infinity, backslash infty, closing curly brackets. So that should say the limit as x goes to infinity. Let's compile. Make sure we're doing everything correctly. That looks good. Put my cursor back in front of the last curly bracket because we still want to be working inside of display style. Now I want the sum as k goes from 1 to n. So backslash sum backslash limits underscore, and I want k equals 1 on the bottom, so in curly brackets k equals 1, close that, caret. On the top I just want n. The curly brackets are optional since it's a single character. So let's make sure we have our sum displaying correctly. Good. Now we want to take the sum of f of x sub k. So x underscore k, and I don't think I need to expand the parentheses. We can see what it looks like when we typeset it, times delta x. Now this is optional, but I'm going to go ahead and put the dot to indicate multiplication. So backslash c dot, that will be a single dot centered vertically, and I'm multiplying that by delta x. Now to get the delta symbol for those Greek letters, it's backslash and the name of the letter. But if I just type all lowercase delta x, I'm going to get the lowercase Greek letter. So let's see what happens there. Okay, so I've got my f of x sub k. The parentheses look fine. I don't need to expand them. I've got my dot, and that is not what I wanted to see for delta x. So the delta symbol, the triangle, is actually the capital letter in the Greek alphabet. So we're just going to go back, and instead of lowercase d, it's backslash delta with an uppercase d. Let's compile that again, and now I have my delta x. We have one last thing to look at that you might run into in calculus notation, and that is vectors. So to get the vector symbol, it's simply backslash VEC. And then in curly brackets, what you want to put the symbol over. So I'm going to call this vector v. Vector v is equal to, and let's do the ij notation. So we have our first component, v sub 1, times vector I, so backslash VEC, vector I, plus v sub 2, so v underscore 2, times vector j, so backslash VEC and j in the curly brackets. And that is equal to, if we want to write this in component form, I like to use angular brackets. So it would be, for the left angular bracket, it's backslash L angle, and that's going to insert the bracket. So now we need our first component, v sub 1, comma, our second component, v sub 2, and then we want the closing bracket, the right angular bracket, so backslash r angle, and that should do it. Let's close math mode, compile, and see how that looks. And I forgot to put 2 backslashes earlier to give myself a little more vertical spacing. Okay, that looks good. So vector v equals v1 times vector I plus v sub 2 times vector j. We're in component form, just v1 comma v2 in the angular brackets. And that concludes this tutorial on calculus notation.